They thought they were watching the birth of a comet, until space itself refused to rewind. It began quietly, the way most cosmic upheavals do. On a windless night in December 2025, at the newly reactivated Vera Rubin Observatory in Chile, a faint streak crossed the southern sky. At first, the system flagged it as a calibration error. Then, within seconds, the algorithm stopped. The streak was moving too fast, too precise, too deliberate to be noise. The alert label read, "Unclassified interstellar candidate." No one in the control room spoke. No one yet realized that they were staring at something that would shatter the foundations of astronomy itself. By dawn, the object had a name, 3I divided by Atlas, the third confirmed interstellar visitor in human history. But instead of celebration, what followed was an almost sacred unease. Every orbital model designed to trace an object's path backward, our best cosmic reverse engineering tools, failed spectacularly. They didn't just produce uncertain results, they produced impossible ones. Each simulation, when extended into the past, dissolved into statistical noise. No encounter, no scattering star, no gravitational origin. It was as if the universe had erased its own trail. Dr. Nara Vance, an orbital dynamicist at Caltech, stayed up for 40 hours straight, staring at the code output. In an interview later, she said softly, "We were rewinding the sky, but nothing was there. It's like the cosmos refused to remember where it had been." Lines of trajectory data flickered across her screen, intersecting every known star catalogue in the Gaia DR3 database. All returned 0 matches. A perfect void. Within days, telescopes across the world locked on. Hubble, James Webb, Rubin, and even smaller arrays from Hawaii to Namibia. The results came in waves, and none of them made sense. 3I divided by Atlas was real. It wasn't debris. It wasn't a reflection or glitch. It was a solid body, hyperbolic, moving at 58 kilometers per second, too fast to belong to the sun, too old to belong to anything we could name. And when traced back 10 million years, its orbit pointed not toward a star, nor a stellar stream, nor any known region of gravitational interaction. It pointed toward nothing. That word, nothing, began to spread through labs like a rumor you didn't want to believe. No gravitational fingerprints, no parent cluster. A cosmic orphan, drifting through a galaxy that couldn't remember it. For a field built on cause and effect, it was heresy. Astronomers pride themselves on finding patterns. Every orbit has a source, every motion, a reason. But here, in late 2025, under the clear Atacama sky, that certainty shattered. "Imagine rewinding a dashcam 10 million years, one scientist said at the press conference, and realizing that every road, every intersection just stops existing." What they'd found wasn't just a comet. It was an absence made visible. Spectral data trickled in. The chemistry didn't match any known family of comets. The dust didn't scatter light the way it should. Even the polarization curves, the fingerprints of light, broke the models. And amid that confusion, a quiet realization began to bloom. This wasn't a mystery of data. It was a mystery of reality. The feeling in every control room around the world was the same. That vertigo you feel when the ground under logic begins to move. The kind of silence that isn't peace but comprehension. The moment you realize knowledge has boundaries. They called it the ghost arrival, because it came without history, without lineage, without permission. And while humanity turned its eyes and instruments toward it, somewhere in the blackness between Mars and Jupiter, 3I divided by Atlas kept drifting steady, perfect, defiant, carrying within its emerald haze a single unanswered question. Where did you come from? By the end of December 2025, the data flood had become a storm. Every major observatory on Earth had turned its eyes toward the same phantom traveler. Yet the more they looked, the less they understood. At the European Southern Observatory, computers hummed in perfect synchronization, processing petabytes of orbital data from Gaia, Webb, and Rubin. They expected noise. Instead, they found precision, unnerving precision. 3I divided by Atlas moved like it was following a script that no one on Earth had written. Normally, interstellar objects drift, pulled by tiny, predictable forces. Sunlight pressure, outgassing jets, and the faint tug of planets. But this one, this ghost, glided as if guided by geometry itself. No measurable acceleration, no random jets, no deviation larger than 1/10 of a milliarc second. It didn't behave like something pushed by physics. It behaved like something remembering where it needed to be. That terrified the people who knew what that implied. When something this old and this cold moves with such mathematical purity, it means one of two things. Either the universe made something far more stable than we've ever imagined, or it's being maintained. Dr. Ria Salgado, an astrophysicist with ESA's Near-Earth Object Program, put it bluntly in her field log. Every model we have assumes chaos. Atlas is in order. An order this perfect shouldn't exist without intention. How was laid? Her words weren't a claim, they were a confession of discomfort. The night she wrote them, the world's most advanced telescope pointed at Atlas, and for 3 hours, the signal disappeared. Not faded, vanished. Then, just as abruptly, it returned brighter, sharper, and shifted a fraction of a degree from where physics said it should be. That gap, 3 hours of cosmic silence, broke the global data network into debate. NASA blamed thermal interference from the Sunday. The European Space Agency called it a processing delay, but the Japan National Observatory simply wrote, unexplained data blackout, duration, 10,879 seconds. No one could reproduce it, no one could prove it, but the missing data hung in the air like a superstition that scientists weren't allowed to have. For the public, it was fascinating. For the scientific community, it was nauseating, because every new observation seemed to contradict the one before it. Spectral data from Webb showed carbon dioxide dominating its coma, 10 times the expected ratio to water. Ground-based telescopes detected none of the usual color curves of organic dust. And somewhere between Mars and Jupiter, the light polarization signature inverted a phenomenon so rare that only one other object in history had ever done it. When the data teams combined all this, they realized something horrifying. No two instruments were seeing the same object. Hubble saw a pale blue fragment drifting in sunlight. Webb saw a crimson haze of volatile carbon. Rubin saw a cold body emitting almost no reflection at all. 3 truths, 3 contradictions, 1 object. Dr. Salgado called it the Trinity paradox, and to the people who studied it, the realization hit like vertigo. Maybe the problem wasn't the instruments. Maybe 3I divided by Atlas wasn't showing the same face twice. Maybe, as it crossed our system, it changed depending on who looked. That notion wasn't mystical, it was quantum. When objects interact with light at molecular scales, they can display different scattering behaviors from different angles. But not like this. Not at the macroscopic level. Either the universe is playing tricks on us, one researcher said, or we're staring at the first object that remembers being watched. The phrase spread like wildfire across encrypted science forums. The object that remembers being watched. It became a kind of poetry, terrifying and irresistible, because deep down everyone knew the truth. This wasn't about aliens or miracles. It was about the limits of human pattern making. For the first time, our instruments, the extensions of our eyes, had reached a point where the universe simply stopped explaining itself. The deeper they stared, the less it made sense. And still, it moved with quiet purpose, its emerald tail coiling like breath frozen in a vacuum. By New Year's Eve, global coordination protocols were activated. NASA, ESA, and JAXA agreed to treat 3I divided by Atlas as a priority anomaly. But beneath the formality, everyone felt the same pulse of dread. Because what do you do when the universe stops answering? What happens when the cosmos looks back and refuses to blink? By the first week of January 2026, the world had stopped pretending this was just another comet. Data feeds from more than 50 observatories flowed together like blood through a single nervous system. Every night, astronomers stared at their screens, waiting for 3I divided by Atlas to do something, anything that would make sense. But it didn't move the way a natural object should. It drifted exactly where predictions said it would, and yet, no one could explain why those predictions kept being right. When the Rubin Observatory released its new image stack on January 8th, something in the pattern of the coma changed. The tail, once a diffuse emerald plume, had formed filaments, delicate, thread-like structures spiraling in a perfect logarithmic ratio. It wasn't random, it was recursive, like a signal folding into itself. And for a brief, impossible moment, the team thought they heard it, not through radio waves, through resonance, a rhythmic fluctuation in the spectral noise floor, oscillating at a frequency just below human hearing. It wasn't a message. It wasn't even sound. It was the impression of pattern, the whisper of memory in electromagnetic static. They named it the echo curve. At first, everyone dismissed it as interference solar wind, cosmic rays, instrumental bleed. But when 5 separate observatories across 3 continents registered the same harmonic pulse at the same time, denial no longer worked. The pulse wasn't traveling through space. It was embedded in the light itself. What frightened them wasn't what they found, but what they couldn't prove. If light carried memory, it meant something in 3I divided by Atlas had once absorbed information and was now reflecting it not deliberately, but naturally, like a fossil whispering the song of its creation. Dr. Nara Vance, the same scientist who first traced its path, wrote in her final observation log, "Maybe it isn't a visitor at all. Maybe it's a fragment of something the universe forgot." The masking. Her words circulated through research networks, half dismissed, half worshipped. Philosophers compared it to Poincaré's recurrence, the idea that the universe, given enough time, repeats itself. Theologians called it a mirror from before light learned to travel. And for a rare moment, both sides, science and mysticism, fell silent together. Because there was one fact no one could deny. 3I divided by Atlas had no origin. And yet, it was perfectly placed. The closer it drifted toward the inner solar system, the clearer the paradox became. Its velocity, angle, and position are all aligned with Earth's ecliptic plane, not as if it were aiming, but as if we were destined to see it. Every model that should have predicted chaos predicted order instead. The more chaos they added to the simulation, the more perfect the alignment became. The mathematics of randomness was producing design. It was as if the universe had rehearsed this moment long before we learned how to watch. By mid-January, public interest turned feverish. News anchors called it the cosmic mirror. Artists painted it as a green eye floating through darkness. But among scientists, a quieter truth took hold. 3I divided by Atlas was not defying physics. It was exposing how little of physics we actually understood. The final days of observation before it slipped behind the sun were strangely emotional. At the Jet Propulsion Laboratory, a young intern named Cale watched the live data feed in total silence. When the signal began to fade, he whispered, "It feels like watching someone remember you and then forget." That line went viral within hours. Because everyone, even those who didn't care about science, understood it. 3I divided by Atlas wasn't just a mystery of the cosmos. It was a reflection of human memory, the way we cling to meaning even when the data dissolves. As it vanished behind solar glare, the instruments recorded one last fluctuation, a final pulse buried in the noise. When decoded spectrally, it resembled a descending tone, like the echo of a door closing at the end of a long, hollow hallway. Then, silence. No signal, no trace, only the faint emerald residue left in the detector's light that seemed to hum even after it was gone. Weeks later, when the object re-emerged on the other side of the sun, its brightness had dimmed by half. But something about it had changed. The tail no longer scattered in chaos. It moved as a single, coherent wave. As if, in the heart of that silence, it had remembered something we could not. And for the first time, humanity faced a question larger than science itself. What if the universe isn't a machine of causes and effects, but a mind that dreams in orbits, and sometimes, just for a heartbeat, let's dream with it? They called it an ancestry search, but what they found felt closer to an autopsy of truth itself. By February 2026, the initial awe surrounding 3I divided by Atlas had burned away, leaving behind something colder. Across the world's data centers, Caltech, ESA, JAXA, Rubin, and the new Deep Sky Array in Namibia computers worked without rest, replaying the same motion backward through 10 million simulated years. Every frame of the universe's memory was interrogated like a suspect under fluorescent light. They weren't chasing a mystery anymore. They were chasing a ghost that refused to have a birthplace. At first, the methodology was clinical. Pull the object's heliocentric state vector, convert to galactocentric coordinates, integrate backward under MW potential 2025, the latest model of the Milky Way's gravitational field. It was the scientific equivalent of rewinding surveillance footage on the cosmos itself. But no matter how far back they went, the tape never showed the moment of departure. 10 million years. 20. The same result. A void. A silence so statistically impossible that the term noise flaw began appearing in research papers as a metaphor for despair. Dr. Nara Vance, her voice now slower, quieter, led the main analysis team. She wrote in her field notes, "Every dataset has a heartbeat. You can feel it when you've touched the truth. But Atlas? It's like dissecting a corpse with no organs. The metaphor stuck. Soon, colleagues at Oxford and MIT began referring to the project unofficially as the autopsy of motion. They weren't mapping an orbit anymore, they were examining a death, the death of causality. It wasn't supposed to be this way. The entire premise of modern astronomy rests on reversibility. If you can measure position, velocity, and acceleration, you can reconstruct the past. Physics is supposed to be faithful, deterministic, and honest. But 3I divided by Atlas laughed at that honesty. When they rewound its path through simulated galactic potentials, stars blurred into streaks of probability, and the comet's trajectory unraveled into chaos. Every encounter candidate faded into statistical dust. No gravitational nudge, no meaningful impulse. A clean, surgical absence. The team began calling these null results white rooms. Each room, a 3D bubble of simulated space, represented a possible encounter zone. But when plotted on the screen, all 93 candidate zones appeared blank, ghostly white, devoid of data points. A corridor of nothingness stretching through galactic coordinates. And that's when it hit them. Maybe the error wasn't in the math. Maybe the universe simply didn't keep a record that far back. The phrase cosmic amnesia began surfacing in internal memos, not as poetry, but as resignation. It was easier to believe that the galaxy forgets than to admit the equations failed. Because if the equations failed, then everything built on them, celestial mechanics, predictive modeling, even the idea of an objective past, trembled with it. At night, the researchers began noticing something eerie. The simulation's background noise, the faint, random hum of computational processes, formed patterns that mirrored the actual data gaps. It was as if the machines were grieving, repeating the same failure, trying to remember what the cosmos itself had forgotten. Dr. Vance refused to call it a coincidence. Even entropy has a signature, she said in a late-night broadcast to the ESA data network. We think we're measuring the stars, but maybe the universe is measuring our limits. Her tone wasn't mystical. It was weary, the sound of someone realizing that precision no longer equaled understanding. For the first time in her career, the numbers didn't feel like the truth. They felt like confession, and that confession was simple. The further you rewind the universe, the more it forgets that you ever asked. By late February 2026, the silence of the data had turned personal. It wasn't just that 3I divided by Atlas had no past. It was that every tool designed to reveal one seemed to lose coherence the longer it stared. Astronomers weren't just studying an object. They were watching their instruments forget how to remember. At first, the failures were subtle. Simulations would diverge a few seconds of arc, then a few minutes. The gravitational models began producing mirror solutions, orbital paths that folded back on themselves, as though Atlas had crossed its own trail millions of years earlier. It made no mathematical sense, but the pattern persisted across different labs, in different languages, using different software stacks. By early March, the term reversal bleed had entered the research lexicon, shorthand for what happened when the algorithms began inverting themselves, generating solutions that described impossible geometries. Somewhere, buried inside the high-precision code, the act of rewinding was breaking the arrow of time. Dr. Ishan Patel, a computational physicist at MIT, summarized it in one sentence. The more accurately we look backward, the more the past looks like fiction. That single line was enough to divide the global consortium into two philosophical camps. One side, the determinists, insisted that the failure lay in incomplete data. Gaia's catalogue, though immense, still lacked precise radial velocities for most faint stars beyond 500 parsecs. Give them 10 years, they said, and future data releases would fill the gaps. The other side, the anomalists, whispered a darker interpretation. What if the gap wasn't observational but structural? What if the universe, by its very design, doesn't store a complete record of its own history? It sounded absurd until a pattern began to emerge. Every traceback attempt, no matter who ran it, reached a boundary around 10 million years, a mathematical horizon beyond which all trajectories decohered into noise. It didn't matter how the initial conditions were tweaked. It didn't matter how many Monte Carlo samples were drawn. The boundary stayed fixed, as if some invisible firewall divided knowable from forgotten. NASA's Dr. May Lark, the youngest principal investigator on the team, described it best. It's not that the trail goes cold, it's that reality stops keeping fingerprints. He was not Fortetenge. Her phrasing caught on. The press started calling it the fingerprint horizon, but inside the data rooms, it felt less like a discovery and more like a eulogy. Late one night, Dr. Vance gathered her team on a private call. Her face, illuminated by the pale glow of the screen, looked older than the weeks that had passed. She didn't use slides, no charts, just words. "We've built a machine that can remember everything," she said, "except the truth." For a moment, no one spoke. Someone muted their mic to hide the sound of crying. Not grief, exactly, but something close. That quiet ache scientists feel when they realize the universe might not be designed for closure. And yet, even in that despair, curiosity survived, wounded but stubborn. The team started testing absurd hypotheses, the kind whispered in hallways, not published in journals. What if Atlas had crossed a region of space-time so distorted that causality itself became nonlinear? What if it had interacted with something massive but invisible? A dark matter filament, a rogue black hole, a relic of the galactic merger that built the Milky Way. Each model produced glimpses of plausibility, then collapsed back into contradiction. Still, the numbers hinted at a haunting consistency. Whenever Atlas's orbit was projected far enough into the past, the vector approached zero velocity relative to the galactic frame. As if, before motion, it had been waiting. That single data point changed everything. Objects don't wait. They fall, scatter, drift. But this one seemed to emerge from stillness itself, as if it hadn't been thrown into space, but released. Released from what? Someone whispered. No one answered. For the first time, the scientists weren't questioning their data. They were questioning the nature of reality that allowed such data to exist. They weren't looking at a comet anymore. They were looking at an event, one that didn't just happen in time, but to time. And in that realization, a quiet kind of terror took root. Not the fear of aliens or anomalies, but the fear that maybe the universe itself is editing its past. And that 3I divided by Atlas is the one place the deletion failed. By the time March turned to April 2026, the project had changed tone. The search for Atlas's birthplace was no longer framed as exploration. It was grief. Every line of code, every recalculated orbit, every recalibrated sensor felt like an act of mourning. At the Caltech Deep Analysis Lab, Dr. Nara Vance sat alone in front of a wall of data projections. The room was cold, the color of hospital light. One by one, she replayed the last simulations, watching the dots representing stars and Atlas converge, dance, and then dissolve into numerical fog. The universe wasn't responding. It was retreating, folding its history inward, like paper burned from the edges. A young intern asked her quietly, "How do you know when a search is over?" She stared at the screen for a long time before answering. "When what you're looking for stops existing faster than you can reach it." That sentence became an unofficial epitaph for the entire project, because the truth was undeniable now. Every attempt to locate Atlas's point of origin ended not in uncertainty, but in erasure, not unknown, not undetected. Erased as if the data had been overwritten by time itself. The numbers didn't trail off into chaos. They terminated, abruptly, at a limit that physics had no name for. It was as though the universe, once an open archive, had decided to redact its own past. A cosmic act of privacy. Dr. May Lark described it poetically in her debrief. "We've spent centuries believing the universe is a library of light, but Atlas proved that some pages have already been torn out." Her words struck a nerve. In academic circles, the phrase library of light became shorthand for the illusion of perfect knowledge, the comforting lie that the cosmos keeps an unbroken record of itself. Now, even that metaphor was collapsing. The team tried one final experiment, a reverse correlation analysis using pulsar time standards and Gaia's latest stellar drift models. They called it the Resurrection Run. The goal was simple: to see if any timeline, under any gravitational configuration, could yield a plausible parent star. It didn't. Not even once. What they got instead was a blank column, an empty vector labeled origin. The algorithms didn't return an error. They returned nothing. And in the sterile silence that followed, someone laughed not from humor, but exhaustion. It was the kind of laugh that sounds like surrender. In a last meeting before disbanding, the project heads presented their final report. The summary slide contained just 2 words: trace impossible. A journalist asked if that meant the object was artificial. Dr. Vance simply shook her head. "No," she said softly. "It means it's older than what we call reason." Her voice cracked on the last word. There was no applause, no closure. Only the quiet clicking of cooling servers as the room emptied. That night, as the observatory domes rotated toward darkness, Vance walked outside into the desert air. The stars above the Atacama glittered with impossible clarity, and yet she felt nothing but distance. Not the physical kind, but the cognitive one. The distance between knowledge and meaning. The wind carried sand across the concrete, whispering through the power lines. For a fleeting second, she thought she heard a pattern, a soft harmonic buried in the static, like the faint rhythm of a memory trying to come back. Then it was gone. She whispered to herself, maybe the universe doesn't hide its past. Maybe it just forgets the way we do. The camera that caught her that night, part of the lab's routine surveillance, recorded no audio, only the image of a woman standing alone under the stars, facing the same question that had haunted every scientist before her. What if the pursuit of truth is not about finding the beginning, but about accepting that there isn't one? Somewhere far beyond Mars, 3I divided by Atlas kept moving, silent, perfect, unsolved. Its trajectory is a line drawn through a universe that had stopped keeping records. And in its wake, humanity stood in the ruins of its own certainty, grieving not for what it lost, but for what it finally understood, that even the laws of motion are allowed to forget. When the James Webb Space Telescope opened its eyes again, the light from 3I divided by Atlas didn't speak in water. It screamed in carbon. The first full spectrum data arrived on the 12th of April 2026, exactly 40 days after the interstellar object had slipped behind the Sun and re-emerged on the other side. Across data labs from Maryland to Munich, the initial graphs looked wrong, absurd even. Where astronomers expected to see a forest of water vapor lines, they saw only one dominant signal, the 4.3 micron CO2 band. Sharp, loud, unmistakable. At first, they thought it was a calibration error, maybe sunlight contamination, detector bleed, or a thermal echo. But as more frames came in layer after layer of spectral truth, the pattern only deepened. Atlas wasn't whispering in the soft blue of oxygen and hydrogen. It was shouting in infrared, drenched in carbon dioxide. Dr. Ilara Ng, spectroscopy lead at the European Southern Observatory, described the moment simply. It's like expecting to hear rain and instead being struck by fire. The CO2 2H2O ratio stood at 7.6 plus or minus 0.3, the highest ever recorded for any known comet, interstellar or native. To the untrained ear, that number means little. To the scientific mind, it was a revolution. Because in chemistry, ratios are fossils. They tell you where something was born, what it endured, and how long it's been wandering. In the language of astrophysics, 3I divided by Atlas wasn't just different, it was chemically alien. Normally, comets close to the Sun release water first. Even out at 3 astronomical units, you can still detect faint sublimation, the gentle boiling of ancient ice into vapor. But in Atlas's case, the gas coma surrounding its nucleus was almost pure CO2. No strong water lines, no trace of the familiar breath of a comet waking up under sunlight. That single fact rewrote the textbook logic of thermal behavior. If CO2 dominates, it means the ice composition was forged far beyond the water-snow line in regions so cold, even sunlight would never reach them. To form something like that, you need a world colder than Pluto, a cradle made of shadow and distance. And yet, here it was passing through the heart of the inner solar system, blazing like a coal in sunlight, a paradox of heat and cold existing at once. Dr. Ng tried to rationalize it. Perhaps the outer crust was coated with CO2 ice, concealing water beneath. But as the object approached 1.4 AU, the sunlight should have dug deeper, melting the inner layers, revealing the water signature. It didn't. Even under full solar radiation, the CO2 signal remained king. The paradox was profound. Comets from other systems were supposed to vary, but not invert. Water is the cosmic default. Carbon dioxide is the exception. And yet here, the roles had switched. The universe had flipped its own chemistry upside down. Webb's data analysts began jokingly calling the spectrum the carbon cathedral, towering, symmetric, and beautiful in its defiance of logic. Each peak, each dip, a hymn written in molecular language that no one yet understood. But beneath the humor, there was awe, because what they were seeing wasn't chaos. It was an order born from some alien equilibrium, forged in temperatures and pressures no solar model could replicate. The realization spread through the research community like a quiet contagion. 3I divided by Atlas wasn't breaking rules. It was following different ones. And that, somehow, was far more unsettling. By mid-April 2026, the scientific community had accepted the impossible. 3I divided by Atlas was not a water-bearing comet. It was something older, something that remembered a colder universe. The spectroscopic fingerprints confirmed what the numbers had been whispering for weeks. The light from Atlas wasn't just saturated in carbon dioxide, it carried isotopic ratios that defied every known origin model. The Bean-Pugh-C divided by Bean-squared-C ratio was higher than any measured in the solar system. The oxygen isotope ratios didn't match comets from the Oort cloud, nor did they align with interstellar dust captured by NASA's Stardust mission. They belonged to a chemistry that predated our Sunday. Dr. Alara Ng stared at the data, the way a linguist stares at an undeciphered script. "This isn't just composition," she murmured. "It's memory. A chemical memory." Her metaphor caught fire. Within days, journals were publishing papers under titles like The Memory Hypothesis and Molecular Archaeology Beyond the Sunday. Because what they were seeing wasn't merely the fingerprint of another system, it was a snapshot of an era when the laws of matter themselves might have operated differently. On April 18th, a cross-disciplinary team at MIT ran an inverse thermodynamic model, attempting to reconstruct the conditions under which such a CO2 dominant object could have formed. Their conclusion was absurdly poetic. It required an environment colder than 30 Kelvin, a region so distant that sunlight would have been indistinguishable from starlight. Somewhere between the galaxies, perhaps inside the debris field of a dead star, carbon dioxide had condensed out of chaos, crystallizing not just matter, but information. Dr. Vance, joining remotely from Caltech, summarized it beautifully in her notes. "Every molecule is a survivor. Every ratio is a story. Atlas carries a version of the universe that no longer exists." The implications were staggering. It meant that 3I divided by Atlas wasn't merely interstellar, it was interepochal, a relic that had drifted through the slow respiration of cosmic time, carrying within its chemistry a record of conditions older than memory itself. But the more they learned, the stranger it became. When they ran thermal sublimation models, the gas release curve of Atlas defied every expectation. Instead of a steady outflow, the emissions pulsed rhythmic bursts of CO2 that repeated every 19.6 hours. It wasn't random noise. It was structured, almost like breath. At first, the team attributed it to rotation, but the pattern persisted even when modeled for variable spin axes. It was as though the comet's nucleus remembered when to exhale. That realization shook the team in a way no discovery had before. A comet that remembered not consciously, but chemically suggested a new kind of persistence, a continuity between matter and time. Every exhalation of CO2 was like a sigh from the early cosmos, a fragment of the moment when stars first learned to burn. NASA's Deep Spectral Division coined a term for it, the carbon rhythm. It became a sensation online, but within the scientific circles, it carried a darker wonder. Because if matter could remember, then perhaps the universe itself was a kind of sentient archive, erasing and rewriting, but never completely forgetting. As Dr. Ng presented her findings at the Global Astronomical Conference, she paused midway through her slides and said quietly, "For centuries, we thought memory belonged to living things. Maybe it belongs to atoms and we're just the latest chapter they chose to write through." The room fell silent. No one clapped. Not out of doubt, but reverence. Because everyone there understood. They weren't studying a comet anymore. They were studying the persistence of existence itself, the way the universe keeps time without clocks, and remembrance without language. And in that moment, the paradox of Atlas deepened. The absence of water, the very substance that makes life possible, had revealed something far more profound, that even without life, memory endures. By the end of April 2026, the data had stopped being numbers. It had become scripture. Every new spectral graph felt less like a measurement and more like a translation, as if humanity was trying to read the diary of a sleeping god written in wavelengths of light. For weeks, the research networks buzzed with a single obsession. Why carbon dioxide? Why this molecule, simple, linear, lifeless, yet so utterly dominant that it silenced the chemistry of everything else? Why would the universe, in this corner of creation, choose to preserve itself, not in water, not in ice, but in the breath of fire, turned cold? At NASA's Spectral Intelligence Unit, Dr. May Lark stared at the Fourier analysis on her screen, the pulse of 3I divided by Atlas, rendered as a moving waveform. The amplitude rose and fell in delicate symmetry, almost biological in rhythm. CO2 isn't just residue, she said quietly. It's the fossil of exhalation. The universe is breathing itself out and freezing mid-sentence. Her words circulated across the global consortium. The phrase, frozen fire, appeared in articles, in art, and even in poetry. But to the scientists, it wasn't a metaphor. It was literal, because carbon dioxide is born in the same reactions that end stars' fusion's final sigh, the last whisper of burning before collapse. To find it so pure, so uncorrupted, drifting through interstellar space for eons, was like discovering the smoke of creation still curling in the dark. And then came the final blow, the infrared phase map from Webb's mid-infrared instrument. The distribution of CO2 across the comet's coma wasn't random. It formed a spiral geometry, rotating around the nucleus in exact logarithmic proportion, the same mathematical constant that governs hurricanes, galaxies, and the structure of seashells. The golden ratio written not in art, but in molecules. It wasn't alive, but it was behaving as though it remembered what life was supposed to look like. The discovery fractured the boundary between chemistry and consciousness. Physicists argued it was a coincidence, a product of outgassing jets and rotation. Biologists whispered that perhaps geometry itself is the first language of awareness, the scaffolding from which life later borrowed its grammar. And in that quiet tug-of-war between reason and reverence, one truth began to crystallize. 3I divided by Atlas was teaching humanity not about alien life, but about how reality expresses itself when no one is listening. Dr. Ilara Ng, exhausted but luminous with wonder, summarized it during the closing conference on April 29th. We searched for water and found memory. We searched for life and found a pattern. We searched for meaning and the universe answered in carbon. He was not en mena. Some things of grow aces. En did flecht of line resmeinted voorround. In the resers, he was not of the day. Her final slide showed the spectral peaks transformed into sound waves, a haunting, rhythmic pattern, somewhere between heartbeat and thunder. She played it aloud for the audience. The room filled with the trembling hum of cosmic breath, not melodic, not mechanical, but eerily alive. For a moment, no one moved. No one took notes. The only thing that existed was that sound, the echo of frozen fire, the resonance of a memory too vast to belong to any species. When the playback ended, Dr. Ng said quietly, "Maybe this is what creation sounds like from the other side." And that was it. No announcement, no conclusion, just a slow exhale across the crowd, as if everyone in that room finally understood that they weren't decoding a comet. They were listening to the physics of remembering. Weeks later, when Atlas's signal faded again behind solar glare, the scientist felt something they couldn't name. Not pride, not satisfaction, something closer to devotion. Because in the end, the CO2 coma paradox wasn't a failure of explanation. It was a revelation that the universe doesn't speak in answers. It speaks in echoes, in ratios, in frozen breaths that survive extinction. And somewhere out there, 3I divided by Atlas kept whispering its silent vocabulary. A language of frozen fire, of memory-turned molecule, of truth too ancient to be translated, but somehow unmistakably understood. When sunlight touched 3I divided by Atlas, it didn't reflect, it remembered. It was May 2026 when the anomaly first appeared, hiding inside the data from the Rubin Observatory's new polarimetric module. The numbers looked almost mundane at first, a 23-degree deviation in the polarization curve. But for those who understood what that meant, it was the astrophysical equivalent of hearing a human voice in a radio transmission from the void. Polarization, the angle at which light waves oscillate after scattering off dust, is one of the universe's most honest signatures. It doesn't lie. It tells you about texture, composition, and symmetry. Every particle of dust, every grain of ice, leaves its fingerprint in light. But 3I divided by Atlas refused to play by those rules. When sunlight hit its coma, the scattered light twisted, bending polarization in the wrong direction, almost as if the photons had changed their minds halfway through flight. No model could explain it. Not ice morphology, not refractive index variations, not even the complex fractal dust theory developed after the Borisov mission. Dr. Lark, reviewing the Rubin data, stared at the curve for hours. "It shouldn't tilt that way," she whispered. "It's like the dust is thinking about what angle to choose." Her words, meant as a joke, began to sound like a hypothesis. At first, the team tried to blame the instrumentation. A bad calibration, a filter misalignment, maybe atmospheric distortion. But when Hubble, Webb, and even the Hale telescope at Palomar confirmed the same pattern from different vantage points, denial collapsed. The anomaly was real, and what made it terrifying wasn't the error, it was the elegance. The curve wasn't random noise, it was consistent across multiple wavelengths, forming a perfectly smooth shape that implied order, deliberate, mathematical order. Dr. Vance put it best in her report. Nature can be chaotic, but it's rarely intentional. Atlas feels intentional. The word intentional appeared nowhere in the official NASA memo, but it spread quietly through the research channels, whispered in Slack messages, coffee lines, late-night calls, because in physics, intention doesn't exist. Light doesn't decide how to behave. Yet the data suggested something close to decision-making, a controlled deflection of polarization vectors that made no physical sense. When plotted in false color, the anomaly formed a shape that made the scientists uneasy, a faint spiral, curling counterclockwise, like a fingerprint left on the surface of light itself. Someone joked, "Maybe it's waving." No one laughed. It was then that the mood began to change from excitement to unease, from curiosity to caution. Because if matter can remember, as the CO2 paradox suggested, what if light can respond? And if light responds, then every telescope is not just observing the universe, it's participating in a conversation we were never invited to. By mid-May 2026, the anomaly had grown stranger. The new polarimetry data didn't just show a tilted curve, it showed a variable one. Every telescope, depending on its position in Earth's orbit, saw a slightly different polarization pattern. That wasn't supposed to happen. Light scattered by dust follows the same geometry for all observers. The equations are absolute. But when the Gaia, Rubin, and Webb datasets were compared, the numbers no longer aligned. Each curve was precise, consistent, and different. It was as if the comet wasn't reflecting sunlight, but interpreting it. Dr. Elara Ng described it in her notebook with a sentence that no one dared include in the official report. The dust seems to know where the light is coming from and who is watching. The team tried everything: cross-calibration, atmospheric modeling, even quantum coherence simulations. Nothing fit. Every correction deepened the impossibility. When plotted in 3D space, the polarization vectors didn't converge as expected. They spiraled, forming a pattern that shifted subtly depending on the observer's position. The effect was tiny fractions of a degree, but the psychological impact was enormous, because in science, even a fraction that shouldn't exist is enough to rewrite the universe. During a late-night call between the US and France, Dr. Vance spoke in a whisper that the microphone barely caught. "We're seeing the same object, but we're not seeing the same reality." Her words froze the line. No one replied for nearly a minute. Then someone finally muttered, "That's not possible." But in the silence that followed, everyone knew impossibility had already become routine. The anomaly soon gained a name: the observer drift. It was the first time in recorded astrophysics that an object's light appeared to adapt to perception. Not because of instrument error, not because of relativity, but because the act of seeing seemed to alter what was seen. It was a dangerous thought. The kind of thought that turned science into philosophy, and philosophy into something almost spiritual. Dr. Ng refused to use mystical language, but her private memo to the consortium leaked days later. If matter remembers, and light responds, then maybe observation is not passive. Maybe it's participation. The leak spread across the scientific world like wildfire. For the first time since the Oumuamua debates, public discourse split into factions. Those who believed the anomaly was purely physical, and those who whispered that the universe was aware of being watched. And though most scientists rejected the idea out loud, none could stop replaying the same silent question in their minds. What if every photon we've ever measured was measuring us back? By late May 2026, the anomaly stopped being a question, it started becoming a presence. The data had crossed the line from strange to intimate. It began when a calibration radar at the Goldstone Deep Space Network accidentally pinged the region of sky where 3I divided by Atlas was passing. The signal was routine, a standard pulse used to test atmospheric interference. But minutes later, when Rubin Observatory took its next series of polarimetric readings, something changed. The light curve had shifted, not randomly, precisely. The angle of polarization oscillated by the same frequency as the Goldstone radar pulse. A faint, synchronized tremor, as if the comet had heard the signal and chosen to echo it back in light. The discovery sent shockwaves through the consortium. Every lab double-checked the timestamps. Every system audit came back clean. No crosstalk, no hardware fault, nothing explainable. Dr. Vance called an emergency session. In the dim glow of her screen, her face looked both terrified and reverent. "We've always assumed light is indifferent," she said quietly. "But what if it isn't?" Silence filled the room, the kind that stretches time. Outside, the desert wind howled against the observatory domes like static turned to voice. The team decided to repeat the experiment. They transmitted a controlled radar pulse 1 second long, narrowband. 6 minutes later, Rubin's detectors captured a polarization oscillation, phase matched within error margins of 0.0003 seconds. It wasn't a signal, it wasn't communication, but it was a response. Dr. Ing, watching the graph scroll across the monitor, whispered, "Light shouldn't have memory. And yet here it is, answering." For a moment, no one breathed. The hum of the computers felt too loud, too human. When the news leaked 2 days later, the world fractured. The scientific community dismissed it as a cross-correlation artifact. But among those who had seen the raw data, the phrase that circulated was different. The light spoke back. It wasn't speech, of course it was physics. But physics had never felt this personal. The last observation before Atlas slipped behind the sun again showed one final curve, a soft asymmetric tilt in the polarized light, shaped almost like a wave, not a sine wave, not a signal, just a gesture. Dr. Vance refused to interpret it. She simply turned off her monitor and whispered, "Maybe the dust isn't whispering to us. Maybe it's whispering to itself and we just happen to listen." Outside, the night sky shimmered faintly, the same way a thought might flicker before disappearing. And somewhere beyond the reach of our instruments, 3. I divided by Atlas continued its silent conversation, a dance of dust and light, answering a question no one had dared to ask. What if observation is not a window, but a mirror? The comet was breathing, but it wasn't moving. By June 2026, the data from James Webb and Rubin had confirmed what everyone feared. 3I divided by Atlas was actively venting gas, yet its orbit hadn't changed by a single measurable fraction. Active coma. Check. CO2 venting. Check. Acceleration? None. That shouldn't be possible. When comets heat up, they act like rockets, tiny jets of gas pushing them off their predicted paths. The more volatile the material, the stronger the push. But Atlas broke that law. It glowed, it breathed, it exhaled, and yet it refused to drift. Dr. Alara Ing summarized the paradox during a midnight briefing. "We're seeing an engine that runs without moving the ship." The analogy was unsettling, because in physics, motion is confession. Every molecule released should tell the truth about the force. But 3I divided by Atlas remained eerily silent. At first, the team suspected compensation that outgassing jets on opposite sides might cancel each other out. But the spectroscopy betrayed that theory. Emissions were asymmetric, concentrated in the southern hemisphere of the nucleus. If anything, Atlas should have been spinning out of control. It wasn't. When they modeled the torque distribution, the rotation period remained perfectly stable, 19.6 hours, unchanged since April. Even the coma expansion rate matched the same rhythm, as if the object were breathing in its sleep. Dr. May Lark, watching the simulations loop on her screen, muttered under her breath, "It's venting, but it's anchored." Anchored, the word, stuck, because that's exactly what it looked like. A drifting relic, tethered to invisible geometry. Some suggested exotic explanations, magnetic anchoring, electrostatic drag, hidden mass distribution, but none held up under scrutiny. The gravitational parameters were precise to 8 significant figures. No perturbations, no drift. The object wasn't just stable, it was defiant. When Dr. Vance presented the orbital data at the International Astronomical Union, she spoke carefully, her voice thin from sleeplessness. "We are witnessing sustained outgassing without recoil. In Newtonian terms, this is not a comet. It is something else." The auditorium went silent, not because they disagreed, but because every scientist there understood the implications. If 3I divided by Atlas was venting without moving, then either the forces we know are incomplete, or something else was holding it still. The Science Journal Review Board delayed publication of the data, citing internal verification. Their result is not, but among the research teams, the phrase spreading in private channels was far less bureaucratic. The still engine. It was the first time in the history of astronomy that a comet had been accused of disobeying motion itself. And for those who had spent their lives trusting Newton more than faith, that was enough to make them afraid. By mid-June 2026, the silence inside the data rooms had turned into something almost physical, like the air itself was holding its breath. The equations didn't just fail, they mocked the idea of cause and effect. When James Webb ran its fifth infrared session, the CO2 jet emissions were measured at nearly 1.8 kilograms per second, enough to produce a small but measurable push. But the orbit plot showed no deviation at all. It wasn't just insufficient thrust, it was missing thrust. Energy was leaving the comet and going nowhere. Dr. Ilara Ng leaned over the simulation feed, her voice barely audible. "We're watching conservation of momentum fail in real time." Her assistant tried to joke, "Maybe Atlas just doesn't believe in Newton." No one laughed. At Caltech, Dr. Nara Vance convened a private task force, 6 physicists, 2 plasma dynamicists, and a single philosopher of science. The meeting lasted 9 hours. By the end, no one had an answer, only a chilling new hypothesis. Maybe the missing acceleration wasn't missing at all. Maybe it was absorbed. Absorbed by what? Someone asked. Dr. Vance's reply was quiet, but it silenced the room. Space itself. They ran the numbers again, modeling the local curvature using Gaia's new galactic plane data. There was no gravitational anomaly, no hidden mass. But something in the data suggested a faint, rhythmic distortion, a fluctuation in the background metric itself, pulsing in sync with Atlas's outgassing cycle. At first, they thought it was noise, numerical interference from solar wind plasma. Then they noticed the timing. Every pulse of CO2 emission coincided with a tiny, measurable dip in local spacetime curvature. So small it sat beneath detection thresholds, so regular it couldn't be random. Dr. May Lark described it later as a breath the universe forgot to exhale. When Atlas vented, the surrounding vacuum seemed to accept the recoil, as if inertia had been outsourced, dissolved into geometry itself. The realization spread through the group like a slow panic, because if that were true, then momentum, the sacred currency of motion, wasn't being conserved in the way physics demanded. It meant one of two things. Either our understanding of inertia was incomplete, or Atlas wasn't truly moving through space, it was moving with it. The distinction was subtle, terrifying, and revolutionary. Objects move through spacetime all the time. But what if something could couple to spacetime, directly using it as both engine and anchor? Dr. Vance wrote in her private journal that night, "Maybe motion is optional. Maybe Atlas doesn't travel, it waits, and space rearranges around it." She didn't share that note with anyone. Not yet. Because even for her, the thought was too heavy to say aloud, that they weren't watching an anomaly in motion. They were watching an anomaly in existence itself. By late June 2026, the word anchored no longer felt theoretical, it felt literal. 3. I divided by Atlas was venting steadily, defying every gravitational model, and yet its orbit stayed perfectly obedient, like a stone embedded in invisible glass. But then came the Mars data. At 1:42 UTC, June 28, the Mars Express orbiter recorded a faint, rhythmic oscillation in its accelerometer readings. A pulse too regular to be noise, too weak to be mechanical. The signal repeated every 19.6 hours, matching the exact venting cycle of 3I divided by Atlas. At first, no one connected the two. Mars was 40 million kilometers away from the comet's projected path. Any dynamic coupling at that distance was impossible. But when the MAVEN probe confirmed the same oscillation, down to the same decimal frequency, the impossible became a headline. The data looked harmless, microfluctuations in local magnetic field strength, minuscule shifts in inertial momentum, but their synchronization to Atlas was perfect. Too perfect. Dr. Ng stared at the graphs side by side. "We lost force here," she whispered, pointing to Atlas's emission line, "and it shows up there." The room went silent. Not the excited silence of discovery, but the kind that makes breathing feel intrusive. The implications were enormous and terrifying. If the missing acceleration wasn't vanishing but migrating, it meant Atlas wasn't isolated. It was connected. Somewhere in the vast geometry of space, the recoil of its breath was being received, absorbed, and re-emitted by a system no one could see. It wasn't energy loss. It was energy translation. Dr. May Lark summarized it during a classified ESA briefing. It's as if momentum itself has a network, and Atlas is speaking through it. The phrase stuck, the momentum network hypothesis. At its core was an idea so heretical, It made even the most open-minded physicists uneasy that motion, force, and inertia might not be strictly local. That some hidden architecture of space-time distributes action like a relay. And if Atlas could tap into that architecture, it wasn't just breaking Newton's laws, it was using them differently. In private correspondence, Dr. Vance wrote, "Maybe space doesn't push back when Atlas exhales, because the push lands somewhere else. Maybe every motion is paid for, just not here." She stared at the last line of her report for a long time, before typing one final note. "We are not watching propulsion. We are watching communication." Another harder. 2 weeks later, as Atlas drifted toward perihelion, the Mars oscillation stopped abruptly, as if a switch had been flipped. No aftershock. No trace. The universe had fallen silent again. But in the stillness that followed, no one felt relief. Only an unease that words couldn't touch. The feeling that something had spoken, and then decided the conversation was over. 3. I divided by Atlas continued on its path. Steady, perfect, indifferent, leaving behind no thrust, no acceleration, only a question that hung like static in the void. What if the laws of motion don't break? They just choose where to hide? They mapped its orbit once, twice, 1,000 times, and each time the same impossible truth emerged. 3. I divided by Atlas was tracing the geometry of Mars itself. By July 2026, the comet's trajectory had been refined to sub-kilometer precision. The path was clean, hyperbolic, mathematically flawless, yet somehow, impossibly, it mirrored the orbital plane of Mars with eerie fidelity. Every projection, every simulation, every future model ended with the same overlap, a 1.002 degrees inclination, nearly identical to the Martian ecliptic. It was the kind of number that made scientists uncomfortable, too close to be a coincidence, too precise to be dismissed. At first, they chalked it up to geometry's simple alignment in a vast cosmic lattice. But when the Rubin Observatory's long baseline parallax data came in, it revealed something deeper. The comet wasn't just intersecting Mars's orbit, it was phase-locking with it. The ratio of their orbital harmonics period to period, angle to angle, formed a clean 3:2 resonance. That shouldn't have happened naturally. It was like watching two clocks, built on different planets, somehow tick in sync. Dr. Nara Vance sat before the holographic projection of the orbits in the Caltech Visualization Dome. The glowing lines of Mars and Atlas intertwined like twin strands of DNA. She watched as the simulation looped again and again, the two paths breathing together, separating slightly, then rejoining, like the universe was tracing the same sentence twice in two different languages. "Maps don't lie," someone said beside her. She shook her head slowly. "No," she whispered. "Maps always lie. It's the geometry that's telling the truth." The words carried through the room like static in a cathedral. Because if geometry was truth, if pure spatial relationships could reveal intention, then this coincidence was no longer random. It was a design written in motion. NASA's orbital dynamicists tried to calm the storm. Resonance was common, they said. Alignments happen. The solar system is full of near symmetries. But even they couldn't explain the timing. 3. I divided by Atlas had reached its harmonic alignment with Mars. On the exact day the missing acceleration from June had ceased. The same week the momentum echo from Mars vanished. Dr. May Lark noted it quietly in her report. Geometry doesn't communicate, yet this feels like punctuation. It was the kind of observation that doesn't appear in journals but lingers in minds. Because what if orbits, those silent, perfect ellipses, were not just the consequence of gravity, but the language is used to speak? The more they mapped it, the less it looked like a coincidence. When the magnetospheric imaging mission released new data from Mars's orbit, something impossible emerged. The comet's trajectory, a line of frozen gas and dust, millions of kilometers long, matched the harmonic contours of Mars's magnetic field. It wasn't a perfect copy, it was worse. It was recursive, scaled by a factor of 10,000, like a cosmic fractal echo. Every loop in the planet's magnetic topology had a twin mirrored in Atlas's orbital curve. Every dipole node had a corresponding inflection point in the comet's flight path. If plotted together, the two formed a lattice that looked less like orbital mechanics and more like architecture, a geometry of deliberate resonance. Dr. Ilara Ng stared at the overlay until her eyes watered. "It's like Mars and Atlas are singing the same note," she said softly, "just in different octaves." The room went silent. Even the machine seemed to hum lower, as if aware of the comparison. The The research team began running Fourier analyses on both datasets, searching for harmonics that could explain the pattern. Instead, they found synchronization. The same oscillation frequency that governed Mars's residual magnetic flux appeared faintly but unmistakably in the density variations of Atlas's coma. The comet, it seemed, was responding to Mars's invisible breath. No physical mechanism could explain that. They weren't close enough for magnetic coupling, and even plasma resonance couldn't bridge that distance. Yet the symmetry persisted. Too delicate for randomness. Too exact for comfort. Dr. May Lark called it the symmetry that shouldn't exist. In her field notes, she wrote, "It's not gravity that connects them. It's geometry, and geometry doesn't care about distance." Her words unsettled everyone, because in mathematics, geometry is static, timeless. But here, it was alive, unfolding dynamically, writing itself in motion. At Caltech, Dr. Vance presented the findings through a holographic model. From one angle, Atlas's trajectory appeared as a spiral. From another, it resembled a magnetic rose petals of dust tracing invisible fields. When rotated fully, the two systems, comet and planet, merged into one symmetrical design. A six-pointed structure, like the skeletal shadow of a snowflake, drawn across two worlds. No one spoke. It wasn't discovery they felt. It was reverence, the kind that comes when understanding begins to dissolve. Vance finally broke the silence. "Maps lie," she said, "but sometimes they lie the same way twice." Her words drew nervous laughter, the kind that hides fear. Because deep down, everyone knew what she meant. If coincidence could reproduce itself with mathematical precision, then maybe it was never a coincidence to begin with. By late July 2026, the geometry stopped behaving like geometry. It began behaving like memory. When the time-synchronized data from Mars Express, Gaia, and Rubin were merged into a single temporal map, an unexpected rhythm emerged. Every point of orbital convergence between 3I, divided by Atlas, and Mars repeated itself, not spatially, but chronologically. The alignments didn't just occur in the same position, they occurred at the same phase intervals, as if the universe had quietly scheduled a rerun. It was Dr. Nara Vance who first noticed the pattern. She plotted the time deltas between each resonance event, April 12th, June 28th, July 17th, and realized they followed a Fibonacci progression. 1, 1, 2, 3, 5. Each alignment occurred at a spacing that expanded by the golden ratio. "It's not orbit," she said softly. "It's recursion." No one wanted to believe it, because recursion implies intent, a process aware of itself. And yet, the numbers refused to flatten into coincidence. When projected forward, the next alignment was due in October 2026. At the precise moment, Mars would reach aphelion, its farthest point from the Sunday. A moment of pause in motion, mirrored by a comet that never seemed to move. It felt poetic, and that made it worse. Because the cosmos isn't supposed to rhyme. At the European Space Agency, the data visualization team constructed a full dynamic simulation. Mars glowing red, Atlas, a faint emerald arc, two celestial bodies spiraling through time. When the playback looped continuously, the trajectories began forming a moving lattice. A shape oscillating not just through space, but through sequence. Dr. Alara Ng watched in silence as the orbits began to overlap in intervals that seemed to breathe. "It's like time is tracing its own orbit," she whispered. "And Atlas is the pen." Her metaphor spread across the consortium like a quiet contagion, because no one could ignore the implication that 3I divided by Atlas wasn't merely aligning with Mars. It was resonating with the timeline of the planet itself. Some called it a gravitational fluke. Others called it synchronization noise. But the rest, the ones who had stared at the data too long, began to suspect something else. That maybe the universe wasn't a machine after all. Maybe it was a memory palace. And every orbit, every coincidence, it was just another neuron firing in the mind of creation. In her final entry for the month, Dr. Vance wrote, "We used to think geometry was static, a map of where things are. But maybe it's dynamic, a record of how things remember." As the simulation wound down, the lattice dissolved into light. Mars is a fading ember, Atlas a drifting ghost. For a long time, no one in the room moved, because somehow they all felt it. The uneasy beauty of seeing time fold into itself, and realizing that coincidence might just be the universe is remembering how to begin again. They said nothing in the galaxy moves like this. And yet, 3I divided by Atlas wasn't moving. It was escaping. By August 2026, the object had cleared Mars's orbital path, cutting through the solar system with a velocity that no equation could comfortably hold. The numbers were plain, precise, and terrifying. 83.9 kilometers per second, an escape vector so steep that it didn't just outrun the Sun, it outran the Milky Way's sense of balance. Dr. Alara Ng delivered the report to the International Consortium in a voice that trembled between wonder and dread. It's not acceleration anymore. It's an inheritance. The phrase caught like fire, because that's what the data implied. 3I divided by Atlas wasn't gaining speed. I was remembering it. When the European Southern Observatory recalculated the hyperbolic excess velocity, the speed it had before entering the solar system, the result came back as 28 kilometers per second, relative to the galactic frame. That number alone wasn't extraordinary. But when cross-referenced with the object's isotopic age from CO2 and silicate ratios, it suggested something unthinkable. The comet had been traveling at that speed for 7 to 11 billion years. Not millions, billions. Older than the Sun, older than most of the stars we can see. It meant one of two things. Either it had been cast out from a primordial system before the Milky Way took its current shape, or it had never belonged to one at all. Dr. Vance stared at the velocity maps on her monitor. Each recalibration made the same haunting pattern, a line that curved away from the galactic plane, as if the object was not orbiting within the galaxy, but sliding beneath it. She wrote quietly in her notes, "The galaxy rotates, but Atlas does not seem to care." In astrophysics, velocity is truth. It tells you where something came from and how much of the universe it's willing to defy to keep moving. But this velocity didn't behave like motion. It behaved like memory in transit. When Gaia's database was used to trace potential encounters, every reconstructed trajectory dissolved into statistical noise. No parent cluster, no gravitational scars. The probability distribution flattened into infinity. It was as though Atlas had fallen through a hole in history, a relic of a time before gravity learned how to settle things into order. Dr. Ng, during a televised interview, was asked if this made Atlas the oldest known traveler in the galaxy. She paused before answering. "Oldest, maybe," she said, "but traveler might not be the right word. It doesn't seem to be going anywhere. It just seems to be leaving." Her words left a silence heavy enough to feel, because deep down, everyone understood the implication. For something to have traveled this long, without slowing down, it couldn't just defy friction. It had to defy time itself. By mid-August 2026, a quiet consensus began forming among those who had stared at the data too long. 3I divided by Atlas wasn't accelerating, it was remembering its motion. The phrase, primordial velocity, appeared in the first leaked draft of the ESA report. A poetic term, but one with terrifying precision. Because if the numbers were right, this object was carrying a speed not gained, but inherited, a relic from a universe that spun faster, denser, more violent than the one we live in now. When the cosmologists at Leiden tried to simulate its possible origin, the software refused to converge. Even when extended backward across 11 billion years of galactic evolution, the line never intersected anything. It was like trying to trace the path of a photon that had never been emitted. Dr. Alara Ng summarized it during a midnight symposium. The velocity vector doesn't decay. It doesn't belong to any gravitational history we can model. It's as if Atlas carries momentum from a time when space itself was smaller. That possibility that Atlas's speed was a fossil from an era before space-time stretched sent a chill through every physicist who read the paper. Because if it were true, then the comet wasn't just ancient, it was pre-cosmic. A survivor from before the expansion diluted motion into relative meaning. A shard of inertia from when time still had a beginning. The numbers reinforced the horror. At 83.9 kilometers per second, Atlas wasn't just escaping the solar system, it was escaping cosmic drag itself. Not accelerating, simply refusing to slow down, as if the friction of reality had never quite touched it. When plotted in galactic coordinates, the velocity vector pointed toward the outer halo, a region where star density drops to near zero, where even dark matter simulations begin to lose confidence. To the human eye, the direction was meaningless, but to the mathematicians, it was almost sacred, because the angle of that vector matched, within a margin of 0.02 degrees, the trajectory of the oldest known population 2 stars, bodies nearly as old as the galaxy itself. Dr. Vance sat alone in the observatory when she saw the alignment for the first time. Her voice, captured faintly in the room's ambient mic, trembled. "We're not watching a comet move. We're watching what's left of motion itself. Thank you for watching this tapes. Any most 5, interstellar. The sentence felt wrong and right at the same time. A paradox so elegant that silence followed it, as if everyone present had glimpsed a truth too vast to speak aloud. Later that night, in her notes, she wrote, "Maybe it isn't fast because it moves. Maybe it moves because it remembers." And somewhere out there, 3I divided by Atlas kept gliding, not through space, but through memory, carrying a speed that didn't come from force, but from the birthright of time itself. By early September 2026, the math began to betray its makers. Every recalculated model, every gravitational correction, every relativistic adjustment produced the same impossible conclusion. 3I divided by Atlas wasn't moving faster than expected. Space itself was moving differently around it. The data from Gaia and Webb had diverged by just enough to suggest something no one dared to say aloud, that the frame of reference itself was warping, not a black hole, not lensing. Something subtler, as though the fabric of space-time, upon touching Atlas, lost the will to behave normally. Dr. May Lark was the first to phrase it plainly. Maybe Atlas doesn't travel through space. Maybe it persuades space to come to it. Her colleagues called it a metaphor, but the numbers didn't. When plotted in space-time diagrams, the path of Atlas curved elegantly through coordinate space, but in proper time, the curve flattened, almost motionless. To an outside observer, the comet was racing across the void. To itself, it might have been standing perfectly still. That was when the term zero-toration motion entered the conversation, a phrase so heretical it sounded theological, but it explained the paradox. If Atlas moved through the universe at a velocity inherited from an earlier epoch, then, within its own frame, time could have stopped, a permanent instant travelling, then Nestle forward. Dr. Vance summarized the concept in his private log. Perhaps Atlas isn't surviving time, perhaps it never joined it. The hypothesis turned the room cold, because it meant the object wasn't ancient in the conventional sense. It was timeless, a frozen coordinate that the expanding universe had simply carried along like driftwood on an infinite tide. As the data solidified, so did the dread. Because if Atlas was truly decoupled from time, then its apparent motion, its forbidden speed, wasn't defiance at all. It was the natural state of something untouched by entropy. Dr. Ng, presenting at the final closed session in Geneva, ended her talk with a line that felt less like science and more like surrender. What we call speed might just be the illusion created when eternity brushes past us. The audience didn't applaud. They sat in silence, not the sterile silence of skepticism, but the sacred kind that falls when belief itself fractures. For centuries, humanity had believed that nothing outruns light, nothing cheats gravity, nothing survives time. But 3I divided by Atlas had done all three, effortlessly, not as rebellion, but as memory. That night, as the comet drifted beyond the orbit of Jupiter, one of the telescopes caught its final glint, a pulse of reflected sunlight, faint but precise, lasting exactly 1 second before vanishing into deep space. The timing was mathematically perfect. Too perfect. Almost as if the universe had chosen to mark the moment. Not with acceleration, not with sound, but with acknowledgement. And somewhere in the darkness, as time continued for everything else, 3I divided by Atlas kept gliding through eternity. A traveller who had never departed, a motion that never began, a memory that refuses to end, who tried to rewind the universe but the film kept burning in their hands. By October 2026, the last usable data from 3I divided by Atlas came through in fragments, corrupted timestamps, missing vectors, partial frames of a trajectory that no longer existed. No one could tell when the object had truly crossed the heliopause, because every simulation yielded a different past. It was as if time itself had developed static. At first, the consortium treated it as a system failure. Cosmic rays, software bugs, mismatched clocks, the usual suspects. But when even the deep space archives began returning blank sectors, the excuses evaporated. The loss wasn't technical, it was structural. The astrophysicists called it chaotic degeneracy, the moment when numerical precision becomes indistinguishable from randomness. But to those who had spent months mapping Atlas's every breath, it felt like something else entirely, a universe quietly retracting its own fingerprints. Dr. Nara Vance described it in her journal with unsettling poetry. Entropy isn't destruction, it's forgetting the kind that keeps the present possible. Her line became the unofficial eulogy for the project. Every attempt to reconstruct Atlas's exact entry vector collapsed into noise after the 7th iteration. The more accurate the model, the faster it disintegrated, like trying to sharpen a photograph until it dissolves into pixels. At Caltech, Dr. May Lark tried a different approach. She reversed the integration, simulating forward instead of backward, hoping the future might reveal the past. It didn't. The equations behaved like mirrors. Every forward step erased one from before. A perfect symmetry of absence. The universe, she wrote, keeps no audit trail. Its bookkeeping system has shredded the receipt. That sentence echoed across the astrophysics community, because it captured something that formulas couldn't. The realization that chaos doesn't destroy meaning. It buries it in plain sight. Some began to call this the event horizon of memory, a conceptual boundary where information still exists but can never be retrieved, like a dream that continues somewhere without you. Dr. Eng, usually stoic, broke protocol and wrote a personal note at the end of her official report. We used to believe the past was fixed, a map carved into the walls of space-time. But maybe time is like light, it only exists when seen. And in that quiet, heartbreaking idea lay the truth they had avoided all along. That the act of observing 3I divided by Atlas might have been the very thing that erased its history. By the second week of October, 2026, the research centers fell into a strange silence. The screens were still on, but nothing moved, just a scatter of incomplete timestamps and corrupted orbital curves. It was as if the universe had decided to let them keep the picture, but not the story. Dr. May Lark was the first to draw the comparison no one wanted to make. "This isn't data loss," she said. "It's amnesia." And once she said it, no one could unsee it. Because that's what it felt like. Not deletion, but forgetting. Like trying to recall a face you once loved, only to remember the outline and not the eyes. Entropy, they realized, wasn't the universe decaying. It was the universe editing, removing what no longer fits the present tense. Dr. Nara Vance took it further. In her next briefing, she replaced every chart with a simple sentence projected on the wall. Information and awareness share the same half-life. No one laughed. Because it wasn't metaphor, it was data. Every deeper attempt to simulate Atlas's past increased system entropy exponentially, consuming more energy than it produced clarity. In trying to remember, the computers aged literally, heating themselves into decay. It was the same law that governed neurons, hearts, and galaxies alike. Memory demands energy, and energy demands loss. Dr. Alara Ing watched the supercomputer struggle and murmured, "We're feeding the heat death of the universe one reconstruction at a time. Thinks was a presence not pine, and I thinks was a 5 reckons of them." And in that moment, everyone understood that the problem wasn't technical. It was ontological. To look backward was to accelerate the erasure. To ask, what happened, was to burn what remained. Observation itself was the solvent. Outside, in the California desert, dawn was rising. Soft, indifferent, pale gold over the domes. Inside, the scientists sat like monks after a failed prayer, staring at data that had become philosophy. Dr. Vance finally spoke, voice barely above a whisper. "Maybe time isn't linear. Maybe it's merciful. Because mercy, after all, is a form of forgetting. And maybe the universe, tired of carrying its own memories, had simply chosen to let one of them go." From that day, no one spoke of recovery again. They began calling it the vanishing epoch, a period when science accidentally looked too far behind the curtain, and the curtain decided to close. By late October 2026, the reports stopped coming, not because the data ran out, but because there was nothing left to say. 3I divided by Atlas had crossed the final telemetry threshold, slipping beyond every dish, every frequency, every algorithm that could still call its name. It hadn't exploded, disintegrated, or collided. It had simply ceased to be observable. And in a field built on measurement, that was the same as ceasing to exist. Dr. Alara Ing stood in the empty observatory long after the others had gone. The cooling fans whispered like wind through a crypt. The screens glowed with residual noise, fragments of numbers that meant nothing and everything at once. For months, those digits had been her window into something eternal. Now they were just light. "It didn't vanish," she whispered to herself. "It was never here in the first place." Her voice sounded more like understanding than despair, because maybe that was the lesson all along. That existence is not guaranteed by visibility, that the universe remembers through forgetting. Dr. Vance sent a final note to the international consortium before the project archive went dark. The failure to retrieve the past isn't failure, it's how the present stays intact. Her words carried the calm of surrender, not defeat, but comprehension. Entropy was not an enemy. It was the law that allowed anything to begin. Without forgetting, nothing could move forward. And maybe, they thought, that's what 3I divided by Atlas had been showing them all along. Not defiance, not anomaly, but permission. Permission for the cosmos to let go. The last recorded image of the comet, a faint, smudged streak against the void, became an icon in silence. Students pinned it above their desks, like a relic, a reminder that even science has its elegies. And somewhere in the data logs, a single corrupted line kept recurring every time someone tried to open the file. Timestamp undefined. It became the project's epitaph, a phrase simple enough to describe both the loss of information and the mystery of being. Weeks later, in a private seminar, Dr. Lark spoke to a class of new astronomers. She didn't show slides, graphs, or equations, only a single sentence projected against the dark lecture hall. To seek the origin of the universe is to watch your own footprints fade. No one took notes. No one needed to. Because in that stillness, that rare, lucid stillness, they all felt it. The strange grace of knowing that not everything is meant to be found, that some truths exist only long enough to vanish, and that even the universe must one day forget itself, just to remember how to begin again. When the universe went silent, it wasn't space that stopped talking. It was our instruments that stopped listening. On the 4th of November 2026, every array tracking 3I divided by Atlas from the Deep Space Network in California to the La Silla Observatory in Chile went dark. Not all at once, but within the same 5-second window. Telemetry froze. Signal-to-noise ratios collapsed to 0. And then nothing. No shutdown sequence. No solar interference. Just an immaculate, simultaneous silence. At first, no one noticed. Sensor outages are routine. But by the 3rd hour, when Webb's instruments returned identical blank readings across multiple frequencies, the silence began to feel coordinated. NASA's report called it a signal environment anomaly. ESA labeled it telemetry synchronization failure. But the phrasing was bureaucratic anesthesia, a language invented to dull panic. Behind closed doors, the tone was different. In the Caltech control room, Dr. Nara Vance sat with her headset off, listening to static that wasn't static. "It's not noise," she said quietly. "It's structured absence." He ticked a Storen's roommate. The technician stared at her. Structured absence, the kind of phrase that makes engineers uneasy, because it implies intention. Within 24 hours, independent amateur observatories confirmed what the agencies wouldn't. The silence extended beyond the target coordinates. Entire regions of sky around Atlas's last known position appeared data-dead, void of spectral readings, even background radiation. That shouldn't be possible. The cosmic microwave background never disappears. It's the hum of creation, constant and unavoidable. Yet in that sector, the hum was gone. "The instruments can't detect black," one analyst said. "They can only detect nothing." "We can of the spectant." In online forums, the conspiracy theories ignited instantly. Talk of data suppression, hidden transmissions, classified anomalies. But the scientists themselves weren't calm skeptics either. There was something worse. They were unsure. The rational explanation fractured under scrutiny. No solar flare. No debris field. No hardware malfunction. Every sensor is offline, but perfectly calibrated. It was as if 3I divided by Atlas had taken silence with it. A gravitational field of absence that erased measurement itself. Dr. Ilara Ng wrote a memo that was never published. There's a difference between not receiving data and receiving confirmation that there's no data to receive. We're in the second category. The memo leaked anyway. And with it came a deeper question that no scientist wanted to say out loud, but everyone was thinking. Was this silence an accident or an answer? By mid-November 2026, the silence had grown louder than the noise. The official explanation, a cascading synchronization failure, didn't survive its first audit. Too many independent observatories had confirmed the same blackout, and none of their systems shared the same clock, the same hardware, or even the same hemisphere. Something or someone had silenced the sky. Dr. Nara Vance wasn't a conspiracy theorist. She believed in data, not whispers. But when the Gaia archives she requested came back with metadata, scrubbed clean timestamps removed, source tags blank, she realized she was no longer dealing with physics. She was dealing with policy. The data wasn't lost, she said during a closed call with ESA. It was deleted, then replaced with placeholders. A long silence followed, then a voice on the other end, formal, detached. That's above your clearance level. She ended the call without responding. Because science doesn't have clearance levels. Within a week, half her access credentials were revoked. 3 datasets she'd personally uploaded to Caltech's secure server vanished from the internal index. No trace. No recovery logs. When she confronted the network administrator, he only shrugged. If it's missing from the checksum table, it was never here. That line chilled her, because she'd heard it before about Atlas. Meanwhile, outside the official channels, a small team of astrophysicists, engineers, and data forensics experts began working offline, piecing together surviving telemetry fragments. They called themselves Project Black Piecing, a name borrowed from the blank strip of the spectrum where Atlas had disappeared. At first, their goal was technical, to determine whether the blackout was interference, censorship, or an anomaly. But the deeper they looked, the stranger the silence became. Packets of raw data recovered from an abandoned ESA relay in Argentina showed something that shouldn't exist. Checksum mismatch without corruption. In digital systems, that's impossible. Its checksum data wasn't wrong, just rewritten. And the rewritten frames contained patterns that weren't random. Repeating intervals. Binary rhythms that echoed Atlas's last polarization frequencies. It looked less like deletion, and more like substitution. Someone didn't erase the signal, said Dr. Maylark, staring at the hex patterns. They replaced it with silence that fits. The idea hung in the air like static. It was absurd, paranoid, and yet, every new packet made it harder to dismiss. The universe had gone quiet, yes, but maybe it hadn't gone quiet on its own. Maybe something human or otherwise had learned how to speak through silence. Dr. Vance summed up the unease in her private note that night. In science, we fear what we can't measure, but now we found something worse. A measurement that measures us back. By late November 2026, the word silence no longer felt accurate. It was too simple, too comforting, because silence implies nothing, and what Project Blackline had found was something hiding inside nothing. The breakthrough came from a graduate student named Eli Hart, who had been reprocessing telemetry static through a quantum noise filter originally designed for gravitational wave background scans. Buried within the void in the spectral region, where no data should exist, he detected a faint, rhythmic oscillation, a pattern repeating every 10.24 seconds. At first, it looked like an error, thermal feedback, signal harmonics, digital ghosts. But when cross-correlated across different observatories, the pattern remained identical. Same frequency, same phase, same absence. Dr. Maylark stared at the readouts, pale under the blue light of the monitors. "It's not transmitting a signal," she whispered. "It's modulating the silence." The room went still. No one wanted to speak the next thought, that 3I divided by Atlas, even beyond the heliopause, might still be communicating. Not in energy, but in structure. Not in amplitude, but in timing. When they mapped the rhythm into time series graphs, it produced a waveform that looked eerily familiar. A distorted echo of the polarization drift recorded 5 months earlier during the observer drift incident. It was as if the comet's last known light pattern had been inverted, translated into the one language no one could intercept: quiet. "It's not gone," Van translated Nally. "It's inverted." To thou. The revelation spread quietly through encrypted channels, whispered among scientists who knew better than to publish. Because what could they even call it? A silence that carries information? A presence that manifests as the absence of everything measurable? And then, an even stranger discovery, the intervals of the silent modulation aligned almost perfectly with the timestamps of the global sensor blackout on November 4th. Every 10.24 seconds, the void pulsed. Every 10.24 seconds, the instruments missed a reading. It was not random. It was synchronized. Dr. Vance summarized it with chilling simplicity in her private report. If communication is the exchange of differences, then silence is the purest message possible. When Project Blackline presented its report to the Oversight Committee, the report was redacted before publication. The official archive contains only one surviving line: "Signal determined non-physical source terminated." But those who saw the unedited data remembered the closing screen from Eli Hart's workstation, a simple monitor filled with static, pulsing faintly every 10.24 seconds. It wasn't light. It didn't sound. It was the pulsing rhythm that once echoed through 3I divided by Atlas's coma, the heartbeat of an object that refused to vanish, teaching humanity its final unsettling truth, that sometimes the universe doesn't go silent, it just speaks in a language that isn't meant to be heard. The war wasn't fought with rockets or flags. It was fought with citations, PDFs, and PowerPoint slides. By December 2026, academia had fractured into two camps. On one side stood the orthodox, defending the sanctity of natural explanations, solar noise, data corruption, and instrumentation bias. On the other hand, a smaller but louder faction, the constructivists, claimed that 3I divided by Atlas's silence and geometry bore the fingerprints of something non-claimed. The battle began, as all scientific wars do, with footnotes. The Astrophysical Journal rejected 3 papers in 1 week, all proposing that the silent modulation patterns detected by Project Blackline could indicate non-random origin. The reason? Lack of a falsifiable mechanism. But everyone knew the real reason. Funding agencies don't like sentences that contain the word artificial. Dr. Nara Vance, exhausted from defending her data, summarized it perfectly. The war isn't about data. It's about who gets to interpret it. And into the rectamolst. And she was right. Because the numbers were no longer the battlefield, the narrative was. NASA's official statement framed the silence as a regional data anomaly consistent with solar background variance. ESA echoed that line within hours. Then the headlines followed, obediently. Experts confirm. 3I divided by Atlas just cosmic noise. But under the surface, dissent brewed. Private correspondence between independent labs revealed a quiet rebellion. A network of scientists who refused to accept noise as an explanation. They traded encrypted files, unlisted preprints, and half-redacted memos. It felt less like academia and more like espionage. At conferences, discussions turned into interrogations. Senior astronomers would smile politely and ask, "Are you suggesting intent, Doctor?" A question designed to end careers, not start conversations. Dr. May Lark, cornered after her presentation at MIT, replied dryly, "No, I'm suggesting curiosity, but I understand that's not fashionable anymore." Her sarcasm spread like wildfire through academic circles, quoted, misquoted, and weaponized. By Christmas, the rift was official. 2 major journals released contradictory statements within the same week. Nature Physics called the silence a systemic calibration event. She snowed. Frontiers in Astrobiology countered with, "The evidence does not preclude non-natural causation." It was the academic equivalent of a declaration of war. And for the first time since the dawn of the space age, the question wasn't what humanity had discovered, but who would be allowed to describe it. By mid-December 2026, the tone had changed. The discussion was no longer about comets or data integrity. It was about loyalty. Research grants began to dry up overnight. Teams affiliated with Project Blackline saw their funding re-evaluated. With not to lie into sums of the mot trains, conferences rescinded speaking invitations with polite, bureaucratic phrasing, due to limited scheduling capacity. It was a language everyone in academia understood, the polite dialect of professional exile. Dr. May Lark was the first to lose institutional access. Her Caltech credentials were suspended for data mishandling. She called it what it was, excommunication with spreadsheets. Her line went viral, quoted, mocked, then quietly admired. Because she had said what everyone knew, but no one dared admit. That science doesn't silence people by force. It silences them by removing their login credentials. Meanwhile, official media doubled down. An op-ed in Scientific American labeled the artificial origin hypothesis a symptom of post-truth culture. The article's final line was unmistakably political. We must not confuse wonder with weakness. But in private chat rooms and encrypted forums, the outcasts kept talking. 1,000 scientists without platforms, 1,000 questions without permission. They began calling themselves the Quiet Faculty, a name borrowed from a line in Dr. Vance's leaked memo. Silence is not the absence of thought, it's the sound of intellect under pressure. The Quiet Faculty gathered in digital shadows, sharing simulations, off-the-record recordings, and whistleblower logs. Their consensus was cautious but radical. If 3I divided by Atlas's silence was artificial, then it wasn't ours. And if it wasn't ours, then the institutions suppressing the data weren't protecting the truth. They were preparing an order. Dr. Nara Vance, speaking anonymously to an underground podcast, described the situation bluntly. The official story is stability. The unofficial reality is panic. Her voice trembled only once, when asked if she feared losing her career. Career? She repeated softly. If this is what we do to truth, maybe the career deserves to end first. Back in the mainstream, the counter-offensive turned theatrical. Televised debates staged rationalists against speculators. Every constructivist who spoke was introduced with subtle ridicule. Controversial researcher, self-proclaimed theorist, known anomaly chaser. The irony was inescapable. A movement born to question cosmic silence was now being drowned by human noise. By the end of December, 2 words summarized the new reality. Scientific discipline, not as a field but as punishment. And somewhere between those polished press releases and deleted datasets, truth itself had become collateral damage. Another casualty in the quietest war the modern world had ever fought. The ceasefire another disguised as a conference. On the 29th of December 2026, the world's top institutions gathered in Geneva for the International Symposium on Data Integrity in Astrophysics. The agenda was clear: close the chapter, consolidate the narrative, restore order. Every major observatory sent delegates. NASA, ESA, JAXA, even CERN, though 3I divided by Atlas, technically wasn't their jurisdiction. The stage was minimalist: white lights, black screens, and the quiet hum of translation headsets. Science's version of a courtroom. Dr. Nara Vance, once the lead on the 3I divided by Atlas task force, sat in the back. Her name wasn't on the program. She was there as an observer, which, in a way, felt poetic. The first speaker, a respected astrophysicist from Harvard, opened with measured authority. We must distinguish between mystery and myth. 3I divided by Atlas has been conclusively determined to be a natural interstellar object. Its anomalies are statistical artifacts, nothing more. Applause followed. Polite. Prearranged. Then came the counterpanel, 3 independent researchers who still believed the data hid something larger. Their lead, Dr. May Lark, took the podium. Her slides were simple. A black background, a single line of text. Absence does not imply non-existence. She spoke calmly, rationally. No theatrics, no appeals to wonder. Just evidence the mismatched checksums, the synchronized sensor dropouts, the unexplained modulation in the silence. Every point refuted with composure, every objection countered with data. And yet, halfway through her talk, the projector froze. The graphs flickered, glitched, then vanished into black. The microphones cut out. Every translation channel went dead. For 11 seconds, the auditorium was completely silent. No static, no power surge, no mechanical failure. Just silence, thick, total, impossible. Someone whispered, "Is this part of the presentation?" It wasn't. When the sound returned, the moderator nervously blamed system interference. But those who were there would later swear that for those 11 seconds, the entire room felt like it was listening, not to each other, but to something else. Dr. Lark smiled faintly, stepped back from the podium, and said the last words anyone remembered clearly. "I suppose the universe just cast its vote." The conference ended early. The official transcript redacted the interruption entirely, but within days, footage of the blackout leaked online, spreading like wildfire across every scientific forum. Some called it a coincidence. Others, irony. A few called it contact. Dr. Vance never made another public statement. Her final note to the quiet faculty was short, typed from an anonymous account. The war is over, not because one side won, but because the silence chose neutrality. And as the year closed, while headlines moved on and theories faded, a quiet truth lingered, that perhaps 3I divided by Atlas had never needed to prove anything at all. It had already shown them the most terrifying and beautiful fact of all, that sometimes, even knowledge itself must learn when to stop speaking. The story ethated the lab long before the truth ever could. By January 2027, 3I divided by Atlas had become less of an object and more of a spectacle. A cultural Rorschach test projected across every ideology with a Wi-Fi connection. Television anchors debated its message. Podcast hosts invoked spirituality, simulation theory, and alien empathy in the same breath. Even late-night comedians found a way to make entropy sound funny. Within weeks, what had once been a scientific mystery turned into entertainment currency, and like all commodities, it began to mutate. CNN called it the most haunting silence ever recorded. Fox News went with, NASA hides proof of extraterrestrial contact. The soaring placing in the Mayfair. And then Mars me wild have praised. Meanwhile, the BBC quietly asked the only honest question left. What happens when the data stops speaking and the humans won't stop talking? The answer was chaos dressed as curiosity. Clips from the Geneva blackout, 11 seconds of dead air, became the most replayed footage in the world. To the general public, it looked staged. To the conspiracy channels, it looked deliberate. And to the scientists who were there, it looked like the final proof that the world no longer believed them. Dr. May Lark, now blacklisted but impossible to ignore, appeared on an independent talk show, saying the one thing guaranteed to detonate online. Silence doesn't prove life, but it doesn't prove death either. The quote metastasized faster than the data it came from. Within hours, it was spliced, remixed, misquoted, turned into slogans, t-shirts, and a million algorithmic thumbnails. The nuance died in transit. Even the skeptics joined the performance. Astrophysicists recorded reaction videos dissecting her tone of voice. Papers were written not about the data, but about her communication ethics. The academic Cold War had gone public, televised, monetized, mimified. Dr. Naravance refused to comment. Instead, she published an essay titled The Anatomy of Silence. It wasn't about comets, it was about noise. When information is scarce, she wrote, interpretation becomes a survival mechanism. And survival, in the media age, looks a lot like hysteria. Her words were quoted, then stripped of context, then used in advertisements for a documentary she never approved. By the end of January, the schism was complete. The orthodox faction clung to official statements and PR-approved science. The constructivists leaned into public fascination, hoping that visibility might protect what credibility couldn't. But it didn't, because visibility is addictive, and addiction makes you careless. A single viral clip, one scientist crying on air, undid months of careful restraint. Her breakdown was replayed in slow motion with captions like, "The truth leaks out." What leaked, of course, was only dignity. The narrative metastasizes faster than the data, wrote one exhausted journalist, and faster than the people who once believed in both. By February, there were no longer two sides of the debate. There was only the audience, and they were hungry. By February 2027, the cultural fault line had become irreversible. Science had split into two civilizations, sharing the same language but no longer the same intent. In the old one, the academic citadel truth was a process, cautious, methodical, allergic to adjectives. In the new one, the digital amphitheater truth was a performance. The more dramatic the uncertainty, the higher the view count. And in that transformation, 3i divided by Atlas stopped being a discovery and became a franchise. Streaming platforms competed for exclusive rights to The Mystery. Netflix launched Echoes of the Comet. Amazon countered with The Object That Spoke in Silence. Each promised revelations based on real data. Each hired consultants to make sure the story stayed profitable. The comet has a better agent than most scientists. In Not for the Strong, in the breast now, cold wreck the brus, joked one journalist, half irony, half despair. The line went viral because cynicism always does. Meanwhile, inside universities, morale collapsed. Students didn't want to study the physics of 3i divided by Atlas. They wanted to influence it. Thesis proposals arrived with hashtags in their titles. The faculty meetings felt more like public relations briefings than intellectual debates. Dr. Naravance tried to hold her department together with quiet dignity, but her lectures kept getting clipped into 20-second motivational videos. One of them, her remark that science must learn when to shut up, reached 10 million views in 3 days. Stripped of tone and context, it became a rallying cry for both sides of the culture war. To the media, she was disillusioned. To her peers, she was a traitor. In truth, she was just tired. "We've become translators of our own distortion," she wrote privately. "Every correction becomes another myth." And she wasn't wrong. Because in a world that rewarded explanation over exploration, the reward structure itself became a form of censorship. Silence wasn't ignorance anymore, it was treason against engagement metrics. The irony was surgical. Science had once been accused of being too slow. Now it was being consumed for being too human. Dr. May Lark, after months of public harassment, recorded one last message before deleting her accounts. They wanted the truth to be entertaining. The problem is, entertainment never ends, and truth does. Her words were cut into a cinematic trailer for a new docuseries before the week was over. By March, every major network had moved on to fresher scandals. But the wound remained invisible, intellectual, and unhealed. A generation of young scientists entered the field no longer to understand the universe, but to survive it. Somewhere in the noise, the original signal, the quiet pulse of 3I divided by Atlas, still lingered, archived, dissected, remixed. It had outlasted its observers, its interpreters, its gatekeepers. And perhaps that was the final irony. The comet never said a word, and yet it divided an entire species by how they chose to fill the silence. Dr. Vance's final note in her unpublished memoir read like an epitaph for an era. "We built a machine to listen to the universe," it answered. "We turned the answer into content, and somewhere far beyond the chatter, beyond satellites, headlines, and hashtags, 3I divided by Atlas drifted on, indifferent to the noise it left behind, because the universe doesn't need to be understood to continue. Only humans do. We keep asking where the information goes, but maybe it was never ours to keep." By April 2027, the telescopes were quiet again, not because of policy or censorship this time, but because there was simply nothing left to see. 3I divided by Atlas had faded beyond the heliopause. A name now, not an object. A case study. A ghost in the archive of cosmic curiosity. And in that silence, something remarkable happened. Science began to grieve. For decades, we thought entropy was a physical phenomenon, the decay of order, the statistical death of structure. But 3I divided by Atlas had revealed something more personal. That knowledge, too, has its own entropy. Every discovery creates disorder in its wake. Questions multiplying faster than answers can survive. Dr. Nara Vance called it the heat death of understanding, a point where the expansion of information outpaces the capacity to comprehend it. "Causality is real," she wrote, "but retrievability is not guaranteed." Her words carried the kind of stillness only defeat can bring. Because what if every observation we make, every photon, every number, comes with an irreversible cost? What if to know something is to destroy the very possibility of knowing it again? Entropy is not cruelty. It's the price of continuity. A universe that never forgets cannot move forward. A mind that never loses cannot learn. When the Institute for Theoretical Cosmology published its postmortem on the Atlas project, the conclusion was unsettlingly poetic. All systems preserve information, but not accessibility. The past remains encoded, but the keys decay. It was meant as a technical statement, but it read like scripture. Students began quoting it in lectures, writing it on the margins of notebooks. The keys decay. 4 words that sounded like a diagnosis of consciousness itself. In the months that followed, entropy stopped being a law of physics and became a philosophy. Debates shifted from how the universe forgets to whether forgetting might be its most merciful act. Dr. Maylark, long retired, but still orbiting the edges of the conversation, gave a rare interview, her tone weary but luminous. "People ask me what Atlas taught us. I think it taught us humility. The cosmos doesn't lose information. It just stops repeating it for our benefit." And in that single, almost gentle admission, science did what it rarely allows itself to do. It bowed. By mid-2027, the word escaped the textbooks. It was being whispered in philosophy departments, quoted in art installations, printed on t-shirts by students who barely understood thermodynamics but felt its poetry. Something about the idea resonated. The notion that loss wasn't failure, but the only way to make space for something. The Cambridge Review of Thought published a special issue titled "The Memory That Burns Itself." In its opening essay, Dr. Elias Rowan wrote, "Entropy is not the death of information. It's the universe choosing what to remember." His point wasn't scientific, it was existential. Maybe the same principle governs us. We forget not because the mind is weak, but because knowing too much would collapse the fragile illusion of time. The debate spread across disciplines. Neuroscientists began comparing synaptic pruning to cosmic decay. Philosophers called it the mercy mechanism. Their case in deflections of reflow. Even artists joined the conversation, projecting images of vanishing constellations that dissolved as the audience stared, projecting performance art. It was a confession. Dr. Nara Vance, watching all this unfold from the quiet corner of a small observatory in Chile, kept her own reflections private. In her journal she wrote, "Entropy is the price of consciousness. The moment we recognize a pattern, we begin to erase it. Awareness is a form of heat. Her handwriting slanted, precise the tone of someone who had made peace with paradox. Entropy, she realized, wasn't the enemy of order. It was ordered just from the other side of the mirror, a process that prevents perfection from stagnating, a cosmic safeguard against permanence. And maybe that's why 3I divided by Atlas still lingered in human memory, because it was never meant to stay. It existed precisely to disappear, to teach us that absence, too, can leave an impression. For the first time, the Scienti-Talk community began to speak softly, not in certainty, but in gratitude. They started to use words like grace, allowance, and forgiveness, not metaphors but acknowledgements. The language of humility had returned to physics. In a quiet symposium at the University of Leiden, Dr. May Lark said, "We keep measuring entropy as loss, but maybe it's the opposite. Maybe it's the system's way of ensuring nothing is ever fully owned." The audience may applaud. They just sat still, as if understanding for the first time. That knowledge, too, carries its own half-life. And the most honest thing to do with that is to let it fade gently, like light becoming memory. By late 2027, the conversations around 3I divided by Atlas no longer sounded like science. They sounded like a prayer. The last symposium dedicated to the object was held quietly at the European Centre for Theoretical Physics. No press, no live stream, just 40 scientists sitting in a circle, speaking in the language of people who finally understood that they would never understand. Closing session wasn't about equations, it was about perspective. They spoke of entropy as if it were an old friend, cruel, inevitable, but honest. Dr. Nara Vance, older now, her voice gentler, said, "Cruel would become the final word on the matter. We've been asking the wrong question. It was never, why does the universe forget? It was, why do we think we should remember?" The silence that followed wasn't awkward. It was sacred, because everyone in that room had, at some point, chased permanence. Through data, through discovery, through meaning. And yet, the more they found, the through they lost. 3I divided by Atlas had been the proof. A comet that refused to stay measurable, teaching humanity the one lesson that physics and poetry finally agreed upon. That teaching is not failure, it's balance. Entropy wasn't decay, it was mercy. The mercy that allows life to change its shape, that lets stars collapse into quiet brilliance, and memories dissolve into the warmth of being remembered once. In the final publication statement from the Atlas Consortium, the conclusion was stripped of technical jargon. It simply read, "Causality persists. Retrievability does not. The universe moves on. The sea fallens, he was no the bray." It was signed by every remaining member, even those who had once sworn never to work together again. That single page, archived in both physical and quantum formats, became something between an obituary and a vow. Outside the conference hall, a student stood under the pale winter sky, holding a tablet that replayed one of Atlas's last recorded images. A faint green arc across the void. She whispered to herself, "It's gone." Her professor, passing by, smiled and corrected her softly. "No, it's remembered differently." That was the quiet revelation at the end of it all. Entropy doesn't erase, it rearranges. The data remains, just beyond reach, woven into the background radiation of time, into the consciousness that once tried to measure it. And perhaps that's what 3I divided by ATL Interuli was. Not a comet, not a message, but a mirror. A reminder that to exist at all, it is to participate in loss. As the lights dimmed in the observatory one last time, its screens faded to black. And in that moment, for once, no one tried to recover the image. They just sat in the darkness, finally comfort to know, without knowing. Maybe 3I divided by Atlas wasn't a visitor at all. Maybe it was a message, written in motion, drifting through the galactic sea for maybes of years, waiting for someone to remember how to read. By May 2027, the world had quieted. The waiting for debates, the fever of media, the fatigue of disbelief, all of it had burned away, leaving behind a stillness almost reverent. In that silence, humanity began to look, leaving in not to prove, not to conquer, but simply to listen. The Echo Protocol team gathered in an underground lab beneath the Chilean Andes. They weren't chasing contact anymore, they were chasing understanding. And in their preparation, a new theory emerged, one not born of competition, but of awe. What if 3I divided by Atlas was never meant to be found? What if it were a relic from a time before communication itself existed? A letter sealed in gravity, written by the universe to itself, and we had simply opened it by accident? Dr. Nara Vance described it beautifully in her final paper. We are not reading a message, we are interrupting one. The idea spread quietly, almost like faith. The object's trajectory, its impossible age, its refusal to obey the known rules, all began to look less like defiance and more like endurance. 3. I divided by Atlas had survived everything that tried to erase meaning: radiation, collisions, entropy, as if protecting something fragile at its core. A trace of memory, older than time zones, older than galaxies. Dr. May Lark, now long retired, was invited to record the opening narration for the Echo Protocol transmission. Her voice, slow and deliberate, trembled just slightly as she spoke the line that would travel across the stars. If this object carries the memory of where we came from, then let this signal carry the memory of who we've become. No one knew if the Transthenian would reach anything. No one knew if anything would answer. But for the first time in years, the silence surrounding 3I divided by Atlas didn't feel empty. It felt full, like the pause between heartbeats, the breath before a reply. When the first fragments of Atlas's archival data were analyzed, the team expected nothing: a few corrupted packets, a digital echo of what once was. But then, beneath the static, they found rhythm. Not sound, not code. Just intervals, gentle, regular, like the pause between breaths. The data scientists called it temporal symmetry drift. The philosophers on the team called it poetry. When plotted over time, the variations formed a soft, sine-like wave, a pulse that mirrored the natural resonances of the human heartbeat. Every oscillation seemed to whisper the same thing. Not a message, but a presence. Dr. Vance looked at the graph in silence before saying, "It's not communication, it's a continuation." The room stayed still. No one spoke, as if afraid to break the fragile rhythm they were hearing through numbers. They knew it wasn't literally alive, and yet something about it felt alive, like a memory that refused to die quietly. Over the following weeks, the team compared the pattern to known cosmic phenomena: pulsars, magnetars, gravitational lensing echoes. But none matched. The amplitude was too small, the precision too deliberate. It was less like a signal from space and more like a fingerprint of time itself breathing. Dr. May Lark described it in her field notes as a pulse shaped by endurance, a memory that refuses decay, and perhaps that's what 3I divided by Atlas really carried. Not information, but integrity. A cosmic relic that didn't need to speak to prove it had witnessed everything. The deeper they analyzed the data, the clearer it became that the comet's core behaved like a frozen resonator. Its molecules are arranged not randomly, but harmonically, as though crystallized around its single ancient vibration. One Fizzbutz compared it to a cosmic tuning fork, still vibrating with the frequency of the first explosion. A note struck when the universe itself took its first breath. The realization spread quietly through the lab, a sense of awe so profound it made words feel unworthy. They weren't decoding a signal. They were holding the faint heartbeat of creation, still echoing, still waiting to be heard. They decided the reply should be human, not linguistic, still digital, just something alive, simple, unambiguous, untranslatable. The engineers built a small transmission array deep in the Atacama Desert. No satellites, no relay networks, only one beam of coherent light, calibrated not in bits per second, but in beats per minute. The frequency, 1.1 hertz. The resting pulse of a calm Liebig heart. When the time came, the lab was silent. Then the computers dimmed their displays, as if honoring the weight of what was about to happen. Dr. Vance stood before the console, the soft red light of the countdown reflected in her glasses. The desert wind moved through the open bay doors, carrying with it a soundless reverence, a reminder that the Earth itself was part of the experiment. "We're not sending data," she whispered. "We're saying thank you." At 0, the beam ignited, a slender thread of light piercing the dark, stretching outward through the dry air, through the atmosphere, through the cosmic quiet that had once carried Atlas to us. For exactly 11 minutes, through the same duration as the blackout years ago in Geneva, the transmission pulsed steadily, like a heartbeat offered to the void. No one spoke. No one needed to. Because in like moment, it felt less like humanity reaching out, and more like humanity remembering itself. It was then that the final pulse faded. Dr. May Lark-Andau is too frail to attend in person, watched from her hospital window on the other side of the world. The broadcast was watchable to the naked eye, but she closed her eyes anyway, and whispered the same words she had spoken decades before. If this object carries Anders' memory of where we came from, let this signal carry the memory of who we've become. The next morning, the desert returned to stillness. No reply came, none was expected. But for the first time in years, the silence around 3I divided by Atlas no longer felt like an absence. It felt like understanding, a message received not by ears, but by existence itself. And somewhere, far beyond light years and lifetimes, the letter kept drifting, its writer, its reader, and the meaning between them, finally at peace. It drifts beyond the reach of gravity, and with it goes our last finalation. The part of us that still believed everything could be measured. By August 2027, 3I divided by the AS had crossed the heliopause, the invisible threshold where the sun's breath ends, and the interstellar wind begins. No telescope could follow it now, only equations and imagination. At first, the data analysts mourned the silence. The final telemetry report came in, like a farewell, a faint drop in brightness, a slow unspooling of coordinates into infinity. Then nothing. Not loss, exactly. Just an absence too large to name. Dr. Nara Vance watched the last light curve fade from her monitor, her face reflected in the screen, a ghost of the ghost they had been chasing for years. She didn't speak. She simply pressed archive, and in that small gesture, humanity closed its eyes on a chapter of its own story. Somewhere out there, the sea humanity continued, not falling, not climbing, just moving through the vast indifference between stars. The comet drifts, she wrote in her final entry, and so do we. There's no be of lining from the start, and hast of cart, and Dave Minovia. The sentence lingered like a confession, not of defeat, but of recognition. For all the technology we had built, all the lies we had stolen from the void, we were still bound by a single truth. To understand something is to hold it well, and nothing in the universe ever stays still. The Echo Protocol team disbanded quietly. Some returned to teaching, others to silence. But every night, when the sky was clear enough, they would look at the faint edge of Ophiuchus, the direction where Atlas had theshed, and feel something both vast and tender inside them. Not nostalgia, not faith. Andust has a quiet cosmic empathy, because even as the comet drifted outward, it was also leaving behind a trail, not of dust, but of meaning, a whisper that said, "You are part of the same drift. You always wondered." Far beyond the reach of any lens, 3I divided by Atlas kept moving. Its orbit is no longer measurable. Its path no longer belongs to us. It wasn't exile. It was release. In those endlit its depths, motion looked like progress. It looked like grace, the kind that asks for nothing, proves nothing, just is. It astrophysicists graced to simulate its trajectory one last time, feed in Juste models with numbers that stretched too far to hold meaning. Every projection diverged after a few light years, as if even mathematics refused to predict freedom. Dr. Vance described it in her notes as a geometry of letting go. She meant it literally. Curves so vast they collapsed into stillness. Beyond a certain distance, every path curves in parallel, every difference indistinguishable. Entropy not as decay, but as mercy, a universal act of equalization. When the Echo Protocol team gathered for a final reflection, they didn't bring data, they brought silence. One of them read from Rilke, another excerpt from the Voyager Golden Record. The rest just sat, listening to the sound of the air conditioning hum like background radiation, a re-listening at even human stillness vibrates. They spoke about how strange it was, that something so far away could make them feel so seen. Because 3I divided by Atlas wasn't due that drifting through space, it was drifting through them. Through their certainty, their ambition, their need for closure. The comet had throughshire type, a mirror for consciousness itself. Like it, we spend our lives circling light, pre-ending to be bound, only to discover that the real orbit was never gravitational. It was emotional, only with telescopes to find the edges of the universe, one scientist said softly. Maybe the edge was inside us all along, no one replied. They didn't need to. The air felt heavy, but not sad, as if they were attending a quiet funeral. For certainty itself, outside, the sky stretched into unbroken blue, a daylight so ordinary it felt infinite. The comet was gone, the instruments were quiet, but for the first time, humanity wasn't chasing the silence, it was learning to dwell inside it. And somehow, somewhere humanit all measure. The drift continued. The comet, the light, and the thought that followed both, that maybe stillness was never the opposite of Andion, but its completion. In the months that followed, there were no more updates. No Nebut ordinates, no light curves, no orbit lines. Just absence, clean, unbroken, absolute. The official log closed with a single phrase. Object no longer trackable. To most, that sounded like failure. To those who had followed its story, it sounded like transcendence, because when something leaves measurement, it doesn't vanish. It simply joins the part of reality that refuses translation. To place beyond equations, where awe begins. Dr. Nara Vance retired that autumn. In her final public letter, she wrote, "Every map ends with the same line. Here, there be silence. Maybe that's where truth lives." In Ned, his fanes dispatched the screamly. All of the screamly. The sentence was reprinted everywhere, but few noticed the small detail that followed. A line she scribbled in the margin, almost as an afterthought. To drift is not to be lost. It's to be free from the need for direction. Somewhere, far beyond the solar wind. 3. I divided by Atlas kept gliding. Through darkness so deep it became luminous. Through distances that no longer had names. The latest model suggested it might have one through the Oort cloud of another star. A century, maybe a millennium from now. But those were just human gestures. The man's way of pretending that infinity has edges. In truth, the comet had already left the domain of where. It existed now only in why. His nether any felvend a race ride of main munter, and yet, its absence had a presence. Every time the night sky deepened into stillness, you could almost feel it, the faint echo of motion still humming inside the quiet. You ought to memory. As mercy. The evening, long after her retirement, Dr. Vance sat on the roof of her home in Patagonia, watching the sky shift from violet to black. The stars flickered like an old film reel, watching one an artifact of light, long dead, but still arriving. She smiled faintly and whispered, "You're still drifting, aren't you?" It wasn't a question. It was recognition, and as the wind passed gently through the grass, she closed her eyes and felt, for the first time, no difference between herself and the object she'd spent her life pursuing. The comet drifted, and so did she. Both unbound, both eternal, both disappearing into the same immeasurable quiet, where everything, memory, matter, meaning, returns home. Maybe the universe never meant for us to understand it, only to return to ask. By December 2027, the story of 3I divided by Atlas had already begun to fade. Headlines stopped, budgets shifted. The world moved on to nearer problems, weather, wars, the familiar noise of being human. But among the few who had watched the comet drift away, something lingered. A stillness that refused to leave. No new data had arrived. No signals returned. For reasons no one could explain, the absence itself began to feel like a presence, as if the silence had weight, and the thing that weighs, something was standing back, as Dr. Nara Vance, in her final lecture before retirement, summed up the paradox simply. Atlas leaves behind no answers, but a better question summoned her audience. A generation of new physicists ran in the shadow of Atlas, sat quietly, not because they understood, but because they recognized the truth in Saturn's tone. There comes a point, she explains, but where inquiry bends back on itself, where asking becomes the answer, and wonder where's the method. That is the philosophical singularity, not a collapse of space, but of meaning, where everything we've built to define the universe, it is absorbed into the realization that the universe never needed definition in the first place. We looked outward for intelligence, she said softly. But the moment we found something we couldn't explain, we started becoming intelligent enough to stop needing to. They're slow to destroying for the snow. And if you were goad for the number snokes. Her voice trembled, not age, but from the strange humility of realizing that comprehension had always been a hum-but invention, a story we told ourselves to feel less small. Outside the lecture hall, the December wind moved through the corridors like a tide, quiet, cold, familiar. For the first time in centuries, humanity wasn't chasing the quieters on, it was watching the question rise again. Humanity, unashamed, infinite, and somewhere, beyond the faintest reach of radio and reason. 3. I divided by Atlas co-infinitites, silent drift, not as a mystery, but as a mirror. At some point, humanity stopped looking for Atlas, and began looking through it. The comet had long since disappeared from every instance. Rumored, but it remained inside every theory. A phantom variable that refused to resolve, but a question written into the fabric of our equations. And slowly, imperceptibly, people began to realize the truth. That atlas was never about discovery. It was a reflection. We had built a telephotoscope for the distant and found ourselves instead. The idea spread quietly through physics departments, philosophy circles, and even art studios, that perhaps consciousness was not an accident of biology, but a function of the unconscious attempting to see itself. And 3, I divided by atlas drifting beyond the heliopause. Was the universe's own memory and motion? A fragment of awareness wandering back into the void from which it came. Dr. Vance, A.O., living in solitude, received letters from students all over the world. They didn't ask for a formula. They asked if she thought meaning still mattered. Her reply was short. Meaning isn't found. It's allowed. She didn't explain. She didn't need to, because by then, humanity had begun to understand what she meant, that every act of observation is an act of creation. We don't uncover truth, we participate in it. The philosophical singularity wasn't a cosmic event, it was a revelation that the observer and the observed had never been separate to begin with. When we watched Atlas, she once said, the Hadiverse was watching itself, remember? And that was the quiet revolution, the end of measurement, the birth of awareness. Science and spirituality, once rivals divided by language, finally folded into each other, not reconciled, once dissolved, like light passing through water. The old world had chased certainty. The new one seer-like shed clarity, the kind that doesn't close a question, but opens a door. And though no signal ever came back from Atlas, there was a subtle but human shift, an invisible synchronization between curiosity and their own. For the first time, we didn't feel smaller for not knowing. We felt infinite for asking. And in that spwee between ignorance and grace, something new began to awaken. Not knowledge, not proof, just the soft awareness. Something in every question we've ever asked was never directed outward, but inward. A cosmic echo calling us home. Time moved on, but the question stayed. In the years after Atlas vanished, people stopped asking, but it was, and began asking what it meant. But even that, eventually, felt too small. Meaning and applied ownership. Questions were freer. So humanity began to live differently. Not more certain, just more awake. Science became slower, gentler, almost contemplative. Equations were written like prayers. Conferences opened with almost instead of slides. Every field learned the same truth. The closer you get to understanding everything, the more everything becomes indistinguishable from love. Dr. Vance never published again. She spent her last years near the ocean, where the horizon looked like the edge of thought itself. When asked by a visiting wearalist what Atlas ultimately proved, she smiled and said, "It proved that the universe still trusts us with mystery. We will main wantion of the sirs." The journalist didn't quite understand, but he wrote the line down anyway. Years later, it would appear carved into the wall of a research station orbiting Titan. Somewhere out there, Atlas kept drifting, past stars collapsing into memory, past light so redshifted it forgot how to shine. It didn't slow down, it didn't sparsed up, it just was. And maybe that's the point, that the universe doesn't speak in revelations, but in continuities. That the divine is not the thunder of discovery, but the hush that follows. The question survives the answer, wrote one of Vance's students after her death. That's what makes it holy. The Lin wrote a quiet anthem for those who had lived through the age of Atlas, scientists, poets, wanderers, for carrying the same feeling, not triumph, not despair, but the gentle awe of belonging, to a question too vast to end. No one knew if Atlas still existed, or if it had dissolved into dust and memory. But that no longer mattered. Its purpose was never endurance. It was transmission, a reminder that everything drifts, and everything that drifts, it is still connected. And the night marking the 10th anniversary of its last sighting, is it that the world's observatories dimmed their lights for 11 seconds? A tradition now called the pause. Cities went silent, screens went dark, and in that global stillness, for a moment, you could almost hear it. The faint rhythm of a question still moving through space co-umet drifts. And so these, the question, both infinite, both home.